Hello, hello. How's everyone doing today? Woo! Amazing, amazing energy. So my name's Teresa. I'm very excited to be here for moderating the Layer 2 tracks for today's event. So we actually have a very special guest from Optimism today to give the very first talk. He has a very interesting title. Crypto Twitter is wrong. This is how rollups really work. So let's give the warmest round of applause to Kelvin Fischer.
Okay, where does this go? All right, click. Where are we? There we go. Okay. Oh wait. That's a. All right. So I've been kind of ill the last couple of days, sitting on the toilet. So if I seem defeated and disheveled, that's why. But this isn't the first time I was getting ill on this trip. I've been in Bangkok for about a month, or in Thailand. And the last time I was doing this, I started tweeting and getting really mad at people on the internet. And I realized that I'm not the only one that needs to get their shit together. We better start agreeing on stuff or Ethereum is cooked. So that's the new talk. I'm going to start this talk by telling you a little story. It's December 11th, 1998. It's a mild day at Cape Canaveral, Florida. And some smart cookies at NASA are going to send an orbiter over to Mars, right? So they throw that thing on the rocket and then send it off. Wow, yeah, neat, right? Great. So it's a long, intense journey to Mars. This whole thing takes like 9 months, $500 million, a bunch of people's entire lives built into this thing. Goes all the way to Mars, and then it's finally time for orbital insertion, right? So this is what's supposed to happen, right? Rocket goes like this. Oh, look, it orbits Mars, right? That's what we expect. Yeah, that's what we want. But what actually happens is this. Oh no, it's way too low, and then bam, the whole thing falls apart. The whole thing slams into Mars' atmosphere, falls to pieces. So why? What happened? What happened to this thing? Well, the smart cookies at NASA went over to Lockheed, and they said, hey, Lockheed, you know what? Can you pass me that meter stick? And Lockheed's like, yeah. And Lockheed gives the meter stick to NASA, and NASA's like, hey, Lockheed, what? This is a bleeping yardstick. It turns out that Lockheed, the whole time, was building instruments that were returning data in US customary units. Why? Everyone uses metric. But the moral of this story, right, oopsie, sorry. The moral of the story is that shared definitions make or break projects. If you don't agree on the words that we're saying, you're never going to get anywhere. And today, while Ethereum is facing more competition than ever, we're wasting so much time talking past each other. We're all saying the same things with different words, and everyone hates each other. So I asked the internet on Twitter what they think an L2 is, and here are some of the responses I got. An L2 is a chain that settles to an L1. An L2 is a cultural extension of Ethereum. Like cutlery, a layer 2 is a function description, not a specific design or form. And I give up on the other definition. Let's just stop saying L2, it's a nightmare. The reality is that we can't build the future of Ethereum if we keep using these differing definitions. We can't do it unless we have shared, clear definitions. Shared, clear definitions allow us to see the whole picture, right? And you can fill in the gaps. If you're building a puzzle, what do? You build the frame first, and then you fill in the gaps. Right now, we're building Ethereum by just putting puzzles in random pieces. And so we better start writing a dictionary, or we're going to end up like the Mars orbiter. So, call it whatever you want, but I think we need to build this. I think we need to build the Encyclopedia Etherea, and I think we need to get on it now. Like any good dictionary, the first word in any encyclopedia is aardvark, that's right. And Arthur's an aardvark. I don't know why. It doesn't look like an aardvark. It looks like a bear. I don't think that they should have called him an aardvark, but whatever. The next word is rollup. Now, why rollup? Well, when I asked people on Twitter what an L2 is, nobody could agree. But when I asked people what a rollup was, I actually got surprisingly coherent answers. And kind of the average that I got was this. A rollup is just a normal blockchain that uses another blockchain for ordering and data availability. All right, that's that. So let's kind of walk through it. Let's explain this, right? Blockchain 101, what even is a blockchain, right? Let's crack open Ethereum. What is a blockchain? Well, is composed of three main parts. We have state, that's what the world of the blockchain looks like. We have transactions, that's how people change the blockchain. And we have the state transition function, which is the rules by which a transaction actually modifies the state. We have two properties that are really important for any blockchain. We have ordering, right? Now, let's say that Wizard Hat sends 1 ETH to Timmy, and Timmy sends 1 ETH to Pretty Hat person, right? That's fine. We know that. That works. But if we swap the ordering and we say that the first transaction happens second and vice versa, and Timmy tries to send 1 ETH to Pretty Hat person, well, if we look at the initial state, we know that Timmy didn't have any ETH, and so this doesn't work, right? So ordering is really important. No ordering, no blockchain. Data availability is critical, right? What is that? Well, it's really just a fancy way to say that you can actually download the transactions. If you can't download the transactions and they fade away, then the whole blockchain fades away, right? If you can't execute the transactions because you don't have them in the first place, you can't compute the state. No transactions, no blockchain. All right. So blockchains use consensus mechanisms to establish ordering and data availability, and there's an asterisk there, but don't worry about it. But it basically works. So, we know what a consensus mechanism is. We have Bitcoin, right? So whoever has the most money and lights it on fire wins. That's proof of work. We have Ethereum. Whoever has the most money wins. That's great. Very human. Love that. It's not plutocratic at all. So these futuristic systems are complicated and costly. And the reality is that they're very difficult and expensive to build in the first place. I mean, you try to build Ethereum's proof of stake from scratch, good luck. Then they're also challenging to maintain, so even if you didn't build them in the first place, just to run them is really hard. And I think this is underappreciated, but usually you need a token to reward participants, right? Bitcoin has Bitcoin, ETH has ETH. And the reality is that a lot of people, for a lot of reasons, don't want to make tokens. Cool. So rollups solve this problem by outsourcing consensus to another blockchain, right? This is all that a rollup really does. Let's explain how a rollup works by just giving an example. So Timmy wants to send a transaction. What does Timmy do? He sticks the transaction into the mempool on the rollup, just like you would in Ethereum. And then the validator, or sometimes the block producer, and we call it the sequencer sometimes, takes that transaction and shoves it into a block with lots of other transactions. And then it puts on its little Timmy hat, and it grabs that block, and it goes over to the Ethereum mempool, where it tosses the block into an Ethereum transaction, puts the block into the Ethereum mempool, gets picked up by an Ethereum block producer, puts it into a block, right? This is abridged, but it gives you the basic idea. Validators come in, they say, OK, sign off, looks good, take the block, shove it into the Ethereum blockchain. Now, if you open that transaction back up, there you go, there's your rollup block, right? And now there might be older transactions that have older rollup blocks, and older transactions that have older rollup blocks. And because all of these blocks and the block data is just being shoved into Ethereum transactions, you get all of the guarantees from Ethereum about ordering and data availability about Ethereum transactions, right? If you know that Ethereum transactions are going to be ordered, then you know that if you put a rollup block into an Ethereum transaction, it'll be ordered too. So to kind of recap that, a rollup is just a normal blockchain that uses another blockchain for ordering and data availability, right? OK, so if you've watched this talk and you kind of have some idea of what a rollup is, then you might be asking, where does the ZK or optimistic bit come in? Because we always talk about ZK rollups and optimistic rollups, and I never mentioned ZK or optimistic stuff at all in that description. In order to understand this, we first have to talk about bridges, right? What are bridges? Well, you've probably used one before. We kind of know what they do, right? They're applications. They let you send tokens and data and stuff between different blockchains. How do they actually work? Well, all bridges basically work the same way. You have two chains, and then you stick two smart contracts, one on each chain, right? These are two independent chains. And someone comes by, Timmy comes by, and puts an ETH or whatever into the smart contract on the first chain. And then Timmy goes to the smart contract on the other chain and says, money, please. And now the smart contract in the first chain needs to think, well, how am I actually going to verify what happened on OP mainnet? The problem is that this is a smart contract. I mean, if you were going to do this, you would probably just run an OP mainnet node. And it would love to do this as well. You could just run a full OP mainnet node inside of the smart contract, but it's a smart contract. It can't do that. It's a resource-constrained environment, and we're not able to actually verify the full chain explicitly like this. So instead, the smart contract asks for a proof. It asks for a succinct way to verify the state on the other chain. And then Timmy comes up with a proof, gives it to the rollup, or to the, gives it to the bridge smart contract. And the bridge smart contract takes a look at that proof, verifies it according to some rules, and then poops out some ETH on the other side, right? So Timmy walks off, and now you've completed your bridge transaction. This is generally the way that all bridges work. Whether it's a multisig proof or an optimistic proof or a ZK proof, each time what's happening is that a smart contract is using some abridged metric to decide what's going on the foreign chain. So what I want you to get out of this is that proofs are things that bridges use. Rollups don't use proofs. Bridges use proofs, right? And this has some really weird implications. I really want to have you internalize this. Because it sort of means that this word that we've been throwing around, ZK rollup or optimistic rollup, doesn't make a lot of sense. Because rollups use proofs. Or rollups don't use proofs. Bridges use proofs, right? So if it's the bridge, if ZK or optimistic is a descriptor of the bridge, then why are we applying that descriptor to the rollup? Well, where does this come from? I think that there's a lot of historical context. The answer is that basically rollups think that bridges are useful. This is because it's useful to be able to pull economic activity from one chain to another. And so rollup teams build these official bridges, and these bridges, because of the special relationship between a rollup and its parent chain, can be these kind of special bridges that are more secure than bridges between two arbitrary chains. Now, the fact that it's the rollup teams that build these bridges is just a coincidence of the fact that the rollup teams know the most about the thing. But there's nothing really stopping any arbitrary person from building that bridge. Because it's official and because it has the branding of the chain, it becomes naturally popular. And when people put more and more assets into that bridge, it gets more and more influence over the social consensus of the L2. If the L2 wants to fork, the bridge has to agree, right? Or all of those assets on the bridge are not going to be worth anything on the forked chain. So, and then of course at the end of the day, the official bridge has some sort of proof system, and the result is that the rollup gets its name from that official bridge. All right. So really to hammer it home one last time, proofs are things that bridges use. Rollups don't use proofs. Bridges do. So what? What's the point of all this? Well, I'm glad I'm disheveled because I can look really crazy when I'm saying this. But essentially, all this stuff about ZK rollups and optimistic rollups and there being a war and fighting between all these teams is kind of fake news. And we're just creating this tension between teams for no good reason, right? And the other thing is that ZK and optimistic rollup is just really terribly limiting. If you think this way, you can't imagine new things, like what if there's a chain with two massive bridges at the same time, and one's a ZK and one's an optimistic bridge? What, is it a ZK rollup or an optimistic rollup? Who knows? What if it's a chain with no bridge at all, and then someone puts a bridge on that chain, but the person who does that is just a random person? What if there's a chain that posts blocks to two other blockchains? Or if there's a bridge with more than one proof system? All of these things are things that you can imagine if you're not constrained in this way. So again, at the end of the day, Wittgenstein, good quote, limits of my language are the limits of my world. And the reality is that our language just doesn't leave any room for novel constructions. When people want to build something new, they can't because they don't have the language to do it. And so you're stuck with two really bad options, and you can see this. Option number one is you make up a completely new term, right? So first you get L1, L2, L3, optimistic rollup, ZK rollup, plasma, validium, optimium, volition, sovereign rollup. Like, no one knows what any of this stuff is. If I quizzed half of you, you'd all be wrong, right? No one knows what this stuff is. How am I supposed to convince a user to use my product if nobody knows what it is? And the other option, which if you have less scruples, you just do this. You just co-opt an existing term. You take a term that other people like EVM equivalence or rollup or L2 or whatever, and you just decide that your chain is going to have that too, and because we don't have good definitions, everyone loses, right? Every single person loses. Teams lose, users lose. The reality is that everyone's confused. And so our language just isn't flexible enough for people to be able to build these things. The end result of all of this is that no one's working together. You know how many times I've heard that quote? The fact that there's an I think in front of that is insane. What do you mean, I think we're all just building the same thing? We should know if we're all building the same thing, right? It doesn't make any sense. Why are we doing this to ourselves? And we're doing it because we don't have good shared definitions. So I was trying to figure out, a couple weeks ago, I'm scaffolding these slides. I'm trying to figure out how to end this talk. And then this thing happens, and it kind of fits perfectly with the rest of the talk.
Booster coming in hot for booster catch.
Booster FTS is saved.
And I ignite 13 of those Raptor engines, and this view is incredible right now. I can't wait for us to hear the sonic boom.
Booster landing burn startup.
Has caught the booster.
Chip avionics power is launching nominal.
Starship has entered the atmosphere. Starship is...
Those people share definitions. All of them. They all agree on the same thing. And if you're Ethereum today can't do it. But we could, right? We could catch boosters. We could do it. Whatever. But we have to start working together to create shared definitions. If we don't do this, it's never going to happen. So please join me. Try to help write the Encyclopedia Etheria. We've got 2 definitions, right? We've got rollup and aardvark. That's a really good start. And thank you. Please help formalize stuff. Scan the QR code. There's an empty GitHub repo. I'll add aardvark to this later on. And I'll take any and all questions. Thank you very much. Much appreciated.
That was a great talk, Calvin. All right, so we have some great questions over here. Let's go through the first one. Wow, very interesting. Is lasagna a layer 2?
I mean, if your lasagna has 2 layers, I don't think it's very good lasagna. Let's put it that way. Is a croissant a roll-up? Yeah, why not? I mean, might as well be. You could ask someone on Twitter, they'd say yeah. Can we see the rocket launch again? I feel like it might take up too much time, but I'll send you the video afterwards if you come to me.
All right, so I'm going to mark this as answered. What about croissant? Is that a roll-up? Because we do have 1 vote over here.
Wait, which one? Is a croissant a roll-up? Yes, a
The first
croissant is a
one.
roll-up, yep. What are some other terms and concepts that need defining? That's a really good question. I think L2 is a hopeless term, so let's not bother with that one at first. But things like bridge is a really easy thing to define. The stages for rollups, right? Stage 0, stage 1, stage 2, I think those things can be defined very, very well, and that would help a lot of people. And kind of just, I mean, honestly, at the end of the day, more than defining new terms, I'd like for the ecosystem to start throwing away terms and redefining things like sovereign rollup or validium or whatever in terms of these simpler things that we can all agree on.
Cool. And These questions, guys.
When will I be bleaching my hair again? I don't know. I mean, today, I guess. Why not? Great. I'll bleach my hair today, and I'll whatever. Why not? What are some other terms and concepts? We talked about that. Rollups don't use proofs. Bridges use proofs, but rollups use bridges, right? Without a bridge, what distinguishes a rollup from a foreign chain? Well, all chains use bridges, right? The fact that we have bridges is not unique to rollups. The unique thing about rollups is that it allows you to build a special type of bridge that has better security properties than if you just had two completely unrelated chains. But the fact that that's true doesn't mean that that bridge has to be built by the same people that built the rollup, and it doesn't mean that you can only have one of these. And you don't even have to have any of them if you don't want. Since rollups outsource consensus doesn't mean that decentralizing the rollup doesn't make sense. This is kind of a contentious topic. I would say that the correct answer here is that decentralizing the rollup means a different thing than it would on the layer 1, because you have most of your security properties even if you have a centralized block producer or a centralized sequencer. You don't lose liveness, right? Because you can do this special thing between the rollup and the parent chain. And you don't lose safety. And so this is generally why doing stuff like decentralizing the sequencer has been relatively low on the priority list of a lot of rollup teams, because you have very good security properties and you don't really lose much except for this kind of short-term liveness. Now, eventually, short-term liveness will become the most critical part, but usually focusing time and effort on the bridges and making those bridges robust takes up more time for people.
All right, I guess we have a few more minutes for one more question. How does sharding fit into this?
It's what I do on the toilet all day. How does sharding fit into this? I don't know. This is such a confusing question. I could spend a whole minute working on it. I'm going to skip that one.
Perfect. Let's mark.
All right, we can leave it there. Yeah, great.
All right.
Great.
Thank you, Kevin.
Thank you.
Should I say the title for the talk as well? So for those of you who are leaving, thank you for coming. And for those of you who are staying, our next talk will start at 3:30.
2, 1. All right, you can go ahead.
All right, so time for our next talk for today. Our next speaker represents a company that has been at the forefront of privacy in blockchain. I actually hold great respect for their commitment to advancing privacy in the space, powered by an incredible team of cryptographers. Today, we have Adam Domrad, who is deeply invested in applied cryptography. He will be giving a talk on public-private hybrid rollups. Let's give a warm welcome to Adam to the stage.
Hello, everyone. As was mentioned, I'm Adam Domrad from Aztec. I'm a staff engineer. Salati Kap, as we say in Thailand, or others say in Thailand. And the talk today is public-private hybrid rollups, what I think a lot of people consider the next Ethereum frontier. I don't think this is just people working on privacy. I think a lot of projects realize that privacy is a real problem in the Ethereum space, and that in order to protect users, in order to attract more real-world use cases, privacy is absolutely critical. And there's sort of a story to be told here. Back in the day, Steam was using Bitcoin for transactions, and a lot of the problems that they had were related to gas fees spiking, the volatility of the price of Bitcoin. And we here at Ethereum have done a lot of work to try to get a good user experience on Ethereum. I would say the current frontier of Ethereum is very much scaling, and we're almost at the stage where we can say, hey, organizations, look over here. We solved scaling. Ethereum's great. But basically, what I would say would happen is that they kind of do the same toy experiments that they've always done. Real business stays where there's real privacy. I think the difference between the Steam Bitcoin story and today is that back in the day, Bitcoin was kind of considered private. You have pseudonyms. You don't have all of the things like chain analysis that collect all these touch points. And I would say that today it would be a real risk to do mass business on chain. And you think of Vitalik and he buys a silly game and then suddenly it pops up on Twitter. That's like an annoying use case or annoying situation. But you can think of much more dangerous situations where people's entire net worth is being tracked. So at Aztec, we kind of have this definition. Mike at Aztec came up with it. I really like it. Ethereum is an open system. So in an open system, you are broadcasting to people. There's a minimum mark, you could say, that you are, at the very least, signaling an intent to do something. And our gold standard at Aztec is that is all you're revealing about your intent. When someone looks at the blockchain and all that they see is that someone did something in some state, in some function of some contract, I would say that's the highest level of privacy that we could hope for in Ethereum. And I'd say Ethereum needs privacy. I think I wouldn't disagree with our current focus on UX and scaling, but I think it's kind of known that privacy is a big problem. That if we want people to work on Ethereum, do real things, for the average person, you could every so often withdraw to Coinbase, get yourself in a new EOA, and that gives you enough privacy. But that's not a great situation to be in. And Ethereum has its trade-offs in terms of priorities. It has to balance innovation speed and scope. And basically, where innovation happens right now is with layer 2s or rollups, which we've got a great talk on the definition of, but I'm just going to stick with the term rollups. And we need to lead the way with private rollups. And just a quick caveat, privacy is a very large topic, and we do consider it holistically at Aztec. But I won't be talking about, for example, which jurisdiction to worry about when you're deploying your app and you need to have compliant privacy. We actually have our amazing crypto native legal team here. They're big privacy advocates, and privacy advocates very rooted in reality. They have some very exciting meetings with governments talking about privacy in ZK. And they're happy to talk about real world deployments. I'm going to be focusing on the technical matters. And sort of the journey we had at Aztec is, well, Aztec started with wanting to do bonds on chain and quickly realized that no one wants to do bonds where all of their moves are tracked. And that sort of led us to needing privacy and doing privacy on Ethereum. And there's sort of like the EVM model doesn't necessarily work nicely with privacy. What does work nicely with privacy, this is sort of the Zexi model, and I think all private chains essentially use a model like this. And this is sort of taking a step back because Ethereum originally moved away from these Bitcoin-style notes or UTXOs and moved to an account model. An account model makes a lot of sense for public state because if there's sort of a race condition. If you're trying to work on a note and your intent signals a certain note while things are happening in a shared matter. And sort of these chains that have public state with notes kind of have limitations on what you can do in the same block, essentially because of the limitations of using notes for public state. But actually for private state, turns out Bitcoin has near the right model. The missing pieces are, I say nullifiers in ZK. It's basically ZK. You can't really have nullifiers without ZK. So the idea of a nullifier is that, okay, we have our chunks of money. That's maybe a very easy way of looking at what a note is or a UTXO. And you want to use, in some way, a chunk of money. It could be data, but just for an easy example, let's say it's a chunk of money. And you can only use it if a nullifier doesn't already exist. And what is a nullifier? It's essentially a relationship, mathematical through a hash function. And only you really see whether a nullifier exists for your note. And you provide a ZK proof, so sort of ZK in the sense of actual zero knowledge, because you want to prove in your transaction that you have emitted a nullifier maybe for a note you're using, and that also that nullifier corresponds to your note, but you don't want to reveal anything actually about your note. The way that this bar of something happened is achieved is through the fact that actually no one looking at the system knows which notes are active, which ones have been nullified. So to someone looking in, it's just, hey, this note was created here, you don't know who owns it. This nullifier was emitted here, you don't know for which note. And this is sort of the underpinning, I would say, of private smart contracts and computation. And for a practical example that isn't money, we have an example in our repo at Aztec with a card game, and we kind of have like this cute strength and point system. And that's sort of the user data, and then everything else I would summarize as being important for the protocol. And then this is encrypted. Only you can see it as a user, and on your own device, you can't compute with it. Okay, so the premise is public-private hybrid rollups, and really we would love everything to be done privately, as much as makes sense. Sometimes you do want to reveal stuff truly to everyone. But for this talk, we'll use a narrow definition that anything that doesn't fit into this idea of something happened, you're revealing the amounts of transactions, that we're calling public. That means any other information that's not just the parties transacting. If you send someone a note you're encrypting it in a way that they can see it. But anyone not part of the peer-to-peer transaction gleans information. And can everything be private? I think there's answers on both sides. So if you talk about it very strictly, I alluded that Ethereum, when moving to smart contract computation, there's a reason they moved to the account model. And what we're talking about is taking a step back to more of a node model. So kind of by definition, we are undoing some of the benefits of what enables multi-party systems like Uniswap. And it's for a good reason, because privacy, the only real way to do privacy is that the users execute and prove their own transactions. And particularly, I'm going to focus on ZK here. I think it's the most mature privacy solution that can really take the world's transactions. OK, but so at Aztec, actually, we have both. We also have public state. And sort of this but is, OK, something happened, we consider the gold standard. But it's often OK to say, OK, someone did this specific trade, but we don't know who. There's plenty of times that's not OK. If you're trading in such size that, well, maybe you tip off the market, or maybe you're the only person who could trade such size. So actually, you've revealed your identity. Then it's not OK. But we take a very practical standpoint. We have a public part of our chain on Aztec because it is, we definitely believe in the gradients of privacy. And then you can say, you can make an argument for actually yes, that you can get privacy until the last mile and do public shared state. I think the easiest way you can consider, OK, maybe you can't do something like Uniswap, like a fixed function market maker, but you could have a signal chat, and you could post prices on that. And at least from the chain, the chain still has the something happened property. And only your peers that you're advertising to know the details. And then there's obviously other privacy technologies. There's T's, FHE is on the horizon, although still very slow. That can get us to this property, I'd say mostly, because there's always a trade-off here when you're dealing with multiple parties and you want privacy. OK, so what would a hard no world be? I mean, a hard no world really is sort of the status quo right now. Like, the chain's being tracked more than ever. And there's little incentive for a business to do stuff that reveals their business edge on chain right now. And we see cases where user safety is compromised because their actions are on chain. Really, the good news is really there's no hard no for holistic privacy on any chain. Ethereum did not start out as a private chain, but here we are at Aztec building a system for holistic privacy. But that being said, there's many of these rollups, even the ones that co-opted the term ZK. I mean, they use ZK technology, but really they're just validity proofs. And especially looking at ZK Sync, I mean, I love the company, but their marketing is muddling things by using the term private and associating that with ZK, which is private, but really they're just a validity rollup. And these chains make basic privacy hard and holistic privacy very hard still. And OK, so what's the middle ground? And mostly the middle ground that this is largely the way you can think of the public part of Aztec is that you have some private identity. You have portions of your transaction that come from the private world. Namely, you have private account abstraction. You have, you can start something like in a card game example, you may unilaterally work on your deck and hand, and you're able to do that privately, that information is private, and then you want to kick off a public event, which would be revealing your card so other people can can play the game. And so yeah, as I said, identity is always private on Aztec, and I think that is something that any chain can have private account abstraction, as long as you're comfortable with users doing client-side proofs, which is something we take very seriously. We like to build things that actually work on commodity hardware. We go through pains to make sure that our proving system is practical for the people that are using stuff like phones. Because the reality is that that is the only way to do real privacy, is that not only is there the ability to privately prove your transaction, but that you're able to do this in a way that works for everyone. And another important thing we do at Aztec is that we have the same smart contract framework that works in public and private land, and we do nice things like being able to share states, being able to use the same semantics, being able to, as cohesively as possible, work through what are very different execution environments, because we try as much as possible to abstract the fact that these are just running on very different devices. The public part is proven bytecode by bytecode, and it works on sequencers, whereas the private state can only really exist on users' devices. And transactions can be a mix. They typically, just if you think about logically, they kick off from private state because, well, that is the user. To just encode their event, they have to execute everything that is going to happen in private state. The sequencer can't execute that. And the whole thing either succeeds or reverts. So if you start something out in private state and you call something in public, even though you executed, you're the only one who can execute that state. Luckily, to just revert that state is to just pretend your transaction didn't come in. And the way we execute this, so we had a very successful NoirCon. We had Vitalik there. It was super energetic. I was super happy about it. We have the language Noir, which sort of, you can think of it as, I like the term Circom++. It has everything that Circom can do in terms of create circuits. I think uniquely, we also translate to more of a ZKVM bytecode as well. And it looks like Rust. So it's code that developers are used to. You can kind of think like targeting commodity developers. And on top of that, it integrates with a variety of proving systems. So we have the rollup itself for in Noir, and I think this is sort of the main way we're making sure this is ready for complicated use cases, other rollups, other people in Web 2. We're very much making Noir as a public good. And so this is sort of the proving scheme in a diagram for the client side, where we kind of just verify, we have this folding scheme. It compromises, like it has a bigger proof size, but it tries to be the fastest thing possible. Proving systems are getting faster and faster, but still we want to work hard to make sure this works on commodity hardware. And then the folding is recursively verified in the rollup circuit, also with Noir, which actually uses a different proving scheme we call Mega Honk. Okay, so just the last bit. I don't have as much to say here. I think this is sort of, I would say that you get a lot from the scheme I described, but there is that last mile. I think we do want to get to the point where, okay, you want to use something like a DEX. It should be as private as possible. And I think we can do even better by combining technologies and sort of having multiple layers here. The gold standard is to do everything with privacy primitives. All of them have trade-offs, but using them together, I think you can get as far as possible to a last mile result. And here we have stuff like multi-party computation. Definitely we have people in the Aztec space building building stuff like a multi-party order book. We have fully homomorphic encryption, which has caveats. It's slow right now, but something definitely to look out in the long term. We have T's, and I think I would just lump in the same category, app-specific rollups, like this bank diagram here. I think they're kind of the same thing. Like once you have, if you're willing to have someone centralized doing the matching, you can stuff that in a T. I mean, that has good trade-offs because you're no worse if the T is broken. Then you can certainly kind of keep working the private model. And then you also have, just like, OK, you could use Signal, and you could find peer-to-peer people to work with, and that is completely off-chain. So, yeah, thank you for listening. That's sort of the point of the talk, I guess, is to just let you know about the different techniques that can bring privacy to Ethereum, and it's sort of mission critical, I would say. I think it's the next big thing everyone should be worrying about. Thank you.
So Adam, I'm just going to direct you over here.
OK.
All right, cool. So we do have some live questions coming in. Oh, there we go. We will be able to see that. So I can tell public state from private, but can I also do the reverse, shield to private? Do you want to take an answer for this?
Oh, yeah, sure. So, yeah, as I was saying, so you have to think about the model here. The private state is operating locally, so what you're able to, your intent also encapsulates everything executing in private. So doing the reverse, kicking off something from public, well, you can certainly do that, but the usual pattern is that in public state, you give yourself something like a permission that's going to be privately verified, because to operate privately, you have to react to that and do stuff based on your own device. The sequencer can't do it for you.
All right, cool. So if anyone have any live questions, feel free to scan the QR code over here, and the question will pop up on this side. I think we can give it another 20 seconds to see if there's any more questions. Oh, there's another one.
So the word hybrid, the reason I'm using the word hybrid in the presentation title is because we have well, first of all, describing a rollup that has both private and public parts and how we can cohesively work those together, and then also sort of straddling the gradients of different privacy techniques and kind of varieties of full privacy. And I think you can combine these techniques. You can have client-side proving. Client-side proving is sort of the main part of privacy. You could have privacy without a ZK validity rollup. You can just have, for example, like the ZK apps on Ethereum. And the idea is that there's any chain that has public state and uses privacy is a hybrid. But there's sort of more and less holistic ways to do that.
All right, great. I think we're almost at time. So thank you so much, Adam. Yeah, so our next talk will actually start at 4. So feel free to hang around if you want to stay. All right, thank you, Adam. Well, hello, welcome back. So next we have Connor McMenamin from Nethermind to give us a talk on a revenue model for base rollups. And before directing Connor on the stage, I just wanted to tell everyone when the slide shows up, there's going to be a QR code at the very right bottom corner. So feel free to scan for that if you have any questions for our speakers. So let's welcome Connor on the stage.
Hey everyone. There's a little box here just in case I need to sit down on top of the front row. Okay, cool. So, yeah, my name's Connor. That's not my slide. Perfect. Okay. So yeah, I'm Connor. I'm from Nethermind, and today I'm going to talk about a revenue model for base rollups. Now, I wrote this title before I really sort of had an idea what I was going to talk about, and then I realized that revenue probably just refers to income, but base rollups are not just about, or when you're thinking about rollups in general, it's not just about income, it's about income and expenditure, and comparing those two is how you decide if you want to be a part of the base rollup. And I guess not only are we going to talk about like the base rollup as a sort of an entity, but also the entities, like the real life people that are participating in base rollups. So a quick primer on base rollups for anybody who isn't aware but they're lost is a rollup is said to be based or L1 sequenced when its sequencing is driven by the base L1. So basically the L1 proposers are in charge of producing of proposing the blocks for this rollup, and the rollup derives its state from the sequence of transactions that appear on the L1. Now, a lot of rollups might actually you could squint and say that most rollups are like that already, but I guess the key thing is that the L1 proposers aren't supposed to be sequencing the chain. So the goal of today's talk is introduce the players in base rollups. So we're going to look at each of the players and like think about the income and expenditure that they have and should they be playing this game. Identify their income and expenditures. Discuss how likely they are, how these income and expenditures are going to change on the roadmap that's like upcoming, the big changes that we're expected to see, and then motivate you all to, I guess, participate in base rollups and be thinking about these income and expenditure problems that exist. And then, yeah, I mentioned fat stacks for all, but really what that means is everybody has positive P&L when they're playing these games. Okay, so who do we have here? So we have the users. They're like the most important, right? We're always trying to sort of make, although I was on a panel yesterday where we're talking about who should be gaining the revenue in a system, and users were the bottom of the list, but users should be the ones that are gaining something from playing the game, so they're going to be the ones that I'm going to be like driving the revenue for a base rollup. Proposers and sequencers, I'm putting them in the same bracket. ZK provers, so we have this proposer over here and this based blockchain that's accepting the blocks. We have ZK provers, because I guess a stage 2 rollup should have ZK proofs. The DAO, so I guess when maybe some of you are here and you're thinking about the revenue model for base rollup and you're thinking that it's the DAO that we're trying to like create revenue for, but I think there's just too many players in the ecosystem to like fully focus on just the DAO or like whatever the treasury that exists on a DAO, on a base rollup. We're going to be thinking about them along with everybody else. And then also we're going to have to think about these other chains and rollups because they are actually a big driver of the revenue, the income and expenditure for a rollup. So I have the shark from Finding Nemo. So depending on how you look at it, it could be a friend or it could be a foe, and there will be cases where they are both. Okay, so setting the table. So I guess maybe one of the reasons why I got accepted today was because basically when I submitted this talk, we were around June or July, and we were in a situation where Tycho was losing money by posting blocks to L1, which people were focusing on, and people were getting really scared, like base rollups might not have a future, what's happening here? But there was a good reason for this. Tycho wanted to make sure that users were getting a reasonable UX, that they were getting updates every 12 seconds, because base rollups can only confirm blocks when they get posted to the L1. Now again, there's this concept of pre-confirmations, but they aren't live yet. But at the time, Tyco was forcing L1 blocks onto the, L2 blocks onto the L1, while they were only half full less. So they weren't actually generating enough fees to sort of compensate for the costs of posting to L1. But again, this was sort of the P&L that Grow the Pie was generating, right? And the P&L that they were looking at was L2 gas fees collected minus the L1 fees that were paid to post data and proofs to the L1. So that's a relatively simplified model of the revenue, the income minus expenditure for a base rollup. There's actually a lot more components that we need to consider when we're thinking about is this base rollup viable to run. So if you want to get a bit deeper, Nethermind Research did get a little bit deeper at one point, and I guess we're getting deeper by the day. We had this sort of maybe a little more complex model where we were looking beyond the on-chain costs and looking at the sort of the running costs of running a prover, for example. Like running a prover is not cheap. Not only do you have to actually pay the electricity costs for running the prover, you actually have to buy the prover in the first place. So most people today aren't actually buying provers. They're outsourcing to like AWS or any of these internet cloud providers. So there's additional costs that need to be considered there. But there's also additional incomes. So I'm going to get to those in a second. So again, like I guess we're in a situation where maybe, okay, someone says your income minus expenditure is bad. So someone else says it's not actually that bad. And really, everyone is looking at this in sort of a quite imprecise model, and we're not actually able to consider all of the incomes and all of the expenditures. And I guess you could say that we're shooting from the hip a little bit. But these metrics do provide us with some indication of how things are changing, right? If they're getting bad, if they're getting really bad, or if this really is something unsustainable. And in that sort of early stages for Tyco, that was an unsustainable model, but it is getting better, and that's the key. So again, setting the table. This is the fourth slide that's setting the table. I was struggling for titles. So thanks to rollup competition, base users can migrate easily between rollups that have similar network effects. So network effects are a key part of why users will stay on a rollup today, or base rollup today. But base rollups, sort of by the warm fuzzy feeling that base rollups give us, is that they're actually very connected with the L1 and other base rollups. So this network effect is actually potentially strongest or like shared between all base rollups. So the individual rollups don't actually have much network effect. So users on base rollups actually have basically not much switching costs between base rollups. So in this setting, the provider profits, so the providers I mentioned were the provers, the sequencers, and the DAO. In this setting, the hypothesis that I'm claiming is that these profits of all these people must tend to zero, because it's easy for another base rollup to come along, replicate all of the functionality that exists in that base rollup, and basically just remove some of those overheads that the previous one was, that the profits, sorry, the overheads that base rollup was trying to generate. But this zero profit paradigm is far away. There's still a lot, because of all this haziness, because of this wild west that we're in, it's still possible that provers and sequencers can actually be making money. But again, this is going to be a sort of a long road, and we're going to get there incrementally. And again, depending on how you look at the road, like income is tending towards expenditure. You can see that as a bad thing, but you can also see it as a good thing, right? Especially in the case of Tyco. Tyco was when they initially launched, where the expenditure was really greater than income. Getting it close to income and maybe even getting it past the income is definitely a good thing. So how you look at these things is very important. Okay, so on this path to the end game, this zero profit end game, there is going to be increases in income and there's going to be decreases in expenditure. The formatting is supposed to be decreases in expenditure. A little bit on theme with Kevin's talk earlier on, but not like a HD video. So with music. So anyway, as we shed some of the technical debt, or shed some of the sort of inefficiencies of early stage base rollups, we're going to decrease the expenditure, and we're also going to come up with new ways to increase the income. And yeah, basically that's the summary of the sentence at the bottom. Okay, so here's the list, right? So there's no real model as such, right? It's just a list. You have to basically sum up all of these peak components that you have in your base rollup and check, is the left-hand side greater than the right-hand side? And again, there's multiple players in the system. So when we're thinking about base rollup revenue, we have to look at it player by player. So the users have this warm, fuzzy UX or utility that's hard to quantify, but they pay like very quantifiable fees. But we just need to make sure that there is still some utility that these users are getting, and if they stop paying fees, then we probably have to question, are we charging too much, or are we actually generating any benefit to the users? Proposers. The proposers have relatively straightforward costs as well. They collect fees, they generate MEV, or they execute MEV. They also potentially collect issuance. Issuance is a contentious debate, like in terms of who's paying and who's receiving. But L2s or base rollups can create a token and issue it to the proposers. And the costs are L1 posting and running costs. Provers, again, they can collect fees as well, issuance as well. But they have another cost, which is the setup, which is quite a little bit more significant than a proposer, because again, ZK provers are pretty significant pieces of machinery. The DAO sort of actually does have a sort of a unique income source, which is investors. So when base rollup launches, you'll see that there might be a seed round or multiple seed rounds, and that revenue, that investment does pay for a lot of the upfront costs, which again, you see the provers and potentially the proposers. When you don't know what the fees are going to be, you do need some money in the bank to sort of get things rolling. And that's what sort of Tycho were doing at the start, right? And that makes sense. You need to get the users, create the utility, make sure that the UX isn't too bad, and then you start to generate the fees, and potentially the DAO can recuperate those losses for the investors. But the DAO also has significant, I also mentioned proposal fee. Proposal fee is sort of more of a complex topic, but it is possible that the DAO can be collecting money from actually charging proposers on L1 for the right to be a proposer, but that's not going to be a focus today. They also have to pay, so the DAO is important though, because the DAO does have to pay for things like R&D. We can't keep depending on the Ethereum Foundation for funding. We have to sort of go beyond that, especially when we're trying to create base rollups sort of parallel to the Ethereum ecosystem. So some R&D money does need to be generated, and that comes out of the DAO. And there's also governance, running costs of the DAO. And then we have these alt chains and rollups. So what do they actually mean? So when these alt rollups compose with the base rollup, that could be seen as income, right? You're creating UX, you're creating improved utility for users. And that can allow you to charge more fees. But similarly, they also create competition. And with competition comes sort of tighter profit margins. So is income greater than expenditure? I've already sort of touched on why it should be. But in general, if it's not, you can pack your suitcase and you can go to some other ecosystem, some other rollup. The proposers is an expectancy, yes, it should be, right? But we can see that there is new technology coming along, and there's probably going to be more where proposers may not actually be profitable in the short term because they may commit to offering pre-confirmations, for example. And if you offer a pre-confirmation too cheaply, it may be significantly more expensive to renege on that pre-confirmation than just posting it at a small loss on the L1. The prover in expectancy and long term, yes, but again, it may be a substantial cost to pay for proving hardware. So the prover must invest and see that there is a substantial chance of return. And the DAO, again, I mentioned this investment model. Long term is not sustainable, so they need to be investing in, I guess, sustainable infrastructure for these fee mechanisms, these proposer fees, these sequencer fees, and we're yet to see what that's going to look like. But it's definitely going to be very interesting if the DAO can actually recuperate those costs. Okay, so the costs right now are relatively straightforward, but our hope, considering the sort of the tight profit margins from Tycho, is that these will change, right? So I quote this sort of ancient philosopher or alter ego philosopher who says, base income and expenditure is always in flux. You can't step into the same base revenue model twice. What that means is that depending on the day, like as obviously today, when I go to the toilet, I hear people talking about what the markets are doing. Like revenue is changing all the time, right? The fees are changing all the time, but also the technology is changing all the time. So when we think about the base revenue model, we need to have a dynamics way, a framework for thinking about these things. And that's what's sort of going to be the focus next. So here are some of the big changes to base revenue that I expect to see in the future, in the near future. We're going to see cheaper L1 costs. We're going to see proving becoming more efficient. We're going to see prover and builder markets maturing. So a lot of L2s, base rollups, will run their own prover, but there's whispers about prover markets and potentially also builder markets, right? So builders on L1 are generating revenue for the proposers, and that's probably going to happen as well on base rollups as well. So that's going to be an income source for proposers. And shared everything, okay? So I mentioned this composition, but it's definitely going to be a significant area for income and reduced expenditure. So with shared resources or shared block space, shared proving, we're going to get bigger network effects. We're going to get better utilization of the resources that we're using. But we may also have higher costs, right? So how are we going to balance these things is going to be very interesting. So let's go through each one in a little bit of detail. I'm running out of time. Okay, so cheaper L1 costs, right? So EAP 14844 was relatively straightforward. You just have this sort of temporary data that's being posted to L1, and it makes it cheaper for L2s to post data to L1. And then we're seeing proposals like PeerDAS. I don't really know what it is, but I hear it's going to reduce cost significantly. But it uses some pretty significant sampling, or pretty high-tech sampling procedures. You can check out Vitalik's recent blog post for more information. ZK proofs becoming more efficient. This is a bet. I can't speak from personal experience with ZK proofs. I don't have any. But again, we're constantly seeing cheaper proof generation and cheaper proof verification. We're also seeing increasingly bad naming terminology, but again, it looks like they're getting better. So the worse the names get, the better we're going to see these proofs becoming. And we're seeing also more and more investment, more and more teams deploying people to ZK. So I expect this to continue. A market that I saw this morning, but again, it's been taken down. No one's trading on this thing. So the prover and builder market maturing. I mentioned this already. So Uncle Ben mentions that with great competition comes efficient pricing and innovation. And again, that's just what we're seeing on L1, and we expect to see that in L2 as well. So proof of competition, user and sequencers have to pay less fees. And builder competition, we're going to get better UX through more efficient block building, and the sequencers are going to get higher fees. And then shared everything, right? So with shared sequencing comes more MBV, more users. We're going to get higher fees. We're going to be able to charge higher fees, right? So this is, again, increasing the income of the providers in our system. Shared blobs. So right now, Tyco is creating their own blobs. If you can share your blobs, you can get approximately 100% blob utilization. So you're no longer paying you're paying a fixed cost, but you're now getting 100% utilization. You're able to claw back some of the costs that you're paying. Shared proving, we're going to get economies of scale and cheaper L1 verification. So again, these are all sort of things that you're trying to do as a provider to increase your bottom line, or to improve your bottom line. And composability. So less risk and complexity for proposers. You no longer have to use someone like a cross. You can just basically sign a transaction that interacts with a shared smart contract. And pre-comps, it's a big area of efficiency and reduce the cost that we expect to see, and improved UX that will definitely improve the revenue model for base rollups. But it's also going to increase expenses, right? So there's definitely a greater cost for sequencing two rollups together than sequencing them both of them independently. Just because of the increased search base, the greater amount of MBV opportunities that exist. Shared proving, again, similar concept. As far as I understand, if proving two states together is more expensive than proving two individually. But the big question will be, are some of the benefits greater than the increase in proving costs? We're only going to see that when we see what the results of this R&D are. But we definitely are optimistic that we can get these ZK proving costs low and the utility from shared sequencing high. And centralization, I guess that's sort of a tougher one to quantify, but it's definitely a significant risk. And risks are costs in our revenue model. So centralization poses a risk. And we need to be conscious that all of these shared things will add to centralization risks. So conclusion, when you're thinking about the revenue model for your base rollup, you want to basically tot up all of your incomes, take away all of your expenditures, and ask yourself, why am I playing this if I'm losing, and how can I play more of this if I'm winning? base heroes assemble. So again, do your own calculations and innovate on increasing income and reducing expenses. So remember Herodotus Drake. You can't step into the same base revenue model twice. So we want to see less trickles and more waves crashing. All right. So thanks very much, and yeah, appreciate your time.
All right, great talk, Connor. I'm just going to direct you to stand over here for the QA. Yeah, this one will be good. All right, so we do have a few questions. Let's go from the most voted question. How can we reconcile revenue models with the decentralization of ZKP rollups, where multiple sequencers and validators will need to be compensated?
Did the person that wrote this question, could they explain what they mean by reconciliate? Yeah. Or, sorry, yeah. Can we get a mic to that person? Or? Okay. Maybe we can go to the next question while we're waiting. Well, maybe I can touch on my interpretation of the question. So maybe when, in the case of current rollups where we have a centralized sequencer and a centralized prover, it's still not clear if the incomes are greater than the expenditures. Okay, but yeah, we have the mic now. Let's go.
Essentially, how do we, as there's a risk of fees increasing with higher number of validators in L2ZK rollups, what are the risks of that making the situation like more unsustainable, and what are ways in which we can address that?
Well, the good thing about base rollup specifically is that we don't have any validators to pay, right? It's just the L1 proposer. Now, in terms of the multiple provers that may exist, we're basically going to be creating a market, right? And it's a bit like Bitcoin and some of the old arguments for Bitcoin, where you're like, okay, well, I have my hash rate and I have the expected Bitcoin rewards, and if I'm losing money there, I can go to Bitcoin Cash, or I can go to an alternative blockchain. The same applies to any of these prover markets. So if it becomes too expensive, users will stop paying for it, and basically you're going to have to spread out your costs, or just wait until things become cheap again. So it's definitely a risk, and in a fully decentralized system, yes, we're going to be exposed to these things being too expensive. So the only thing we can do is try and make sure that we have fallbacks, like maybe cheaper fallbacks in the case that those things, we are very exposed to fluctuations. But I think pre-confirmations and things like this that allow us to wait maybe 16 blocks or 32 blocks, L1 blocks, where we get to sort of pick and choose where we include things, and maybe pick and choose which provers to pay. That can maybe help to reduce the risk to maybe spikes, let's say. But I'm not sure if that answered your question, sorry.
Great. We do have around 2 minutes for another question. Which one would you like to take, Connor?
Well, I'll go for the shorter one first. If base rollup has a sustainable and positive revenue, can it become a de facto design for the layer 1? Well, I guess so, right? Like at some point, if there is one base rollup that is taking up all of the L1 block space, that is a theoretical possibility with base rollups. That all the computation is being done off-chain on the base rollup. So in that sense, it could be doing all of the execution for the L1, but I'm not sure if it can actually replace the L1, because it is still being sequenced by the L1. So yeah.
All right. Do you want to answer another one?
Okay. I'll go for the other short one. What is the plan to increase the income, but with the scale and expenditure, with scale the expenditure also increases? Yeah, that is a tricky one. So it's like, again, we have to take a bet, right? And we're lucky in the fact that a lot of people like Flashbots, like all of the ZK teams that I mentioned, they're plowing ahead with improved mechanism design, or improved proving systems, improved mechanism design, regardless of, let's say, like any specific end game that may be likely. They're trying to make things cheaper. And if things do become incredibly expensive with scale, we can always scale back, right? As in, there will definitely be a limit to the amount of things that we can merge, the amount of state that we can merge. But right now, we can see that single rollups can survive. And then it's just a case of how can we actually just scale up that the merging of all this state. And that's definitely going to be a really interesting question. But we can always scale back. That's the key.
All right, cool. So we're right on time. Thank you so much, Connor. Yeah. So our next talk will begin at 4:30. Feel free to hang around. All right, welcome back. So next, we have a speaker from Chroma. He said that his Korean name is really hard to pronounce, so he just goes by TA. And he will be giving a talk on advancing OP stack to ZK rollup. So once the speaker slides shows up, you're going to see a QR code on the side. So feel free to scan that QR code if you have any live questions for the speakers. We will be addressing them during the QA session. So let's give a warm welcome to TA from Chroma.
Show too many slides. Hi, how are you guys doing? So, I'm TA, aka Fake Dev. I'm a ZK engineer from Chroma. So today, I would like to share our experience of advancing OP stack into ZK rollup. So we're trying to enhance efficiency and security with zero-knowledge proofs. So for those of you who don't know about Chroma, I want to first celebrate our successes from last year, our mainnet launch. So we were one of the projects built on OP stack. So we were one of the first. We're the very first optimistic rollup with an active fault-proof system. So we utilize ZK proofs for it. And so ZK enables to solve some problems in traditional fault-proof systems. And first, we approach with a circuit-based implementation of ZK provers, but it has a very, very big issue. So we're trying to transit from circuit-based approach to ZK VM-based approach. And lastly, we're also building a ZK backend library to push the boundaries of proof generation speed. So why ZK fault proofs? So in traditional fault-proof systems, it requires a lot of interactions, which leads to high bond amounts, which decreases the level of decentralization. So with ZK fault proofs, we can just narrow it down to a block level instead of instruction level, which requires much less interactions. So it not only reduces the operational cost itself, since there's less interaction, so we need less computation, but also it can significantly reduce the bond requirement. So it naturally leads to better decentralization and security of the network. So moreover, for like Arbitrum Spold, if we apply ZK technology into it, we would be able to reduce the bond requirement significantly. That is usually used for blocking Sybil attacks. Also, Optimism is putting a lot of resources into exploring ZK fault proofs. So we have an announcement that we have received Retro PGF Round 5 from Optimism to explore more on the ZK fault proof side. And this recognition, I think, shows how much important and possibilities are there into building a permissionless fault-proof system with ZK. So we've looked at like our achievements since last mainnet launch, and now I would like to share some our lessons learned and challenges that we've experienced for building ZK fault-proof systems in our mainnet. So the very important fact that we learned is that the circuit-based approach is just not sustainable. So we currently have about like 100K lines of code, which are for custom circuits. So we have to write it in a circuit language like Plonkish. And it's very, very hard to write and debug and verify. So what we're trying to do is check the integrity of EVM state transition function. But we need like several specific custom circuits written in circuit languages to verify that the state transition function, given the input, is done correctly. And back in 2022, Vitalik even mentioned at that time there was no like production-ready ZK EVM circuit codes, but they had a POC version of it in Ethereum's PSC. And back in the days, it was like 35K lines of code, but even Vitalik mentioned that it's never going to bug-free for a long, long time. So it's very prone to errors, very prone to human errors. So to sum up, there are two challenges. Writing the circuit itself is tough because it's hard to audit and debug. And also, since Optimism and Ethereum brings upgrades to their mainnet, to support like full compatibility, we have to keep up with the protocol upgrades they're making, which means that we have to modify circuits again and again every time the upgrades come up. And this could lead to like possibly if we make more modifications, then there will be possibility of more errors, which would like harm our security of our mainnet. So we need a better approach. So now we're trying to take a ZK-VM-based approach because ZK-VMs can give us generality and auditability. What it means is, as I mentioned, in a circuit-based approach, we need to write circuits in a circuit language like Plonkish, which is very unfamiliar. And because of that, the auditors will also have a hard time auditing, and even us can't really verify well that our code is written well. But ZK VMs allow us like flexibility. We can write any program that we want to verify the computation in Rust. And since it's written in Rust, it's very, very better to audit and debug. So now I would like to dive in more to ZK VM area. So how we're trying to move on from circuits to ZK VMs. So as I mentioned, ZK VMs can provide a general purpose environment for verifiable computation. So what it means is that we don't need to implement circuits anymore. We can just write Rust program. And ZK VMs can basically execute the program and give a proof, which proves that the computation was done correctly. So how it works is first, each ZK VM vendor would have a compiler toolchain that can compile a Rust program into, let's say, if it's based on RISC-V, it would turn into a machine code based on RISC-V. And then inside a ZK VM, there's an executor which executes the program and generates what's called an execution trace. Execution trace is basically polynomials bound by some constraints. So back then, we would have to write like circuits to represent some input data into a polynomial and then have constraints for it. But now ZK VM circuits could handle that. So now we can just write Rust code. There's more flexibility. And then in the proving stage, where the ZK VM gives a proof based on the execution trace, it would commit to the trace and then generate a proof. So I have a summary kind of picture that we can compare, like how it's different. So the colored green parts are the code that we used to maintain and we have to maintain. So back then, we would have to maintain like ZK EVM circuits written in Plonkish. So there would be like EVM circuit, RLP circuit, MPT circuit, and transaction circuit, which kind of replicates the behavior of EVM. So it will verify the logic if let's say the transaction body and like the block header and block body comparing with like hash it and then like compare with the block hash. That's what we used to do, but it's very, very tricky. But now, since on the right side, there are ZK VM circuits, so ZK VM circuits would handle that, and instead, we would just write a block execution program, which for us, as an Ethereum layer 2, we would derive the batch from L1 and then execute it on L2. So that would be the program we were trying to write. And some of you might ask, like Vitalik mentioned in 2022, we launched our mainnet in 2023, and then like, why didn't you guys first approach with ZK VMs at first, right? Like, why did you guys write circuits and do all that hard work? That's because back then, ZK VMs were not like performant. So since the proving time is long, within the challenge period we have, there can be possible vulnerabilities, possible attack vector for delay attacks. So that's one of the reasons why we chose a circuit-based approach. But now, Risk Zero calls it continuation, and like SP1 calls it sharding. Like there was a breakthrough called sharding, which with the full execution trace, you can now divide it into a unit called shards. So it's usually represented in the number of cycles of RISC-V. So SP1, they kind of have an optimal number of like 2 to the power of 22 cycles for each shard. And since we can divide it into shards, now we can parallelly generate a proof for each shard and then compress it later into a single shard. So now there's more upside in terms of throughput since we can parallelize proofs. So that's what we're trying to do, and we're almost there shipping it to the mainnet. And now I want to like share more of my thought that what we can explore more in the future to overcome like barriers to become from an optimistic rollup to a ZK rollup. So my concerns about ZKVM-based approach is since ZKVM vendors' business model is usually running a prover network. So they get a delegated proof, and then they generate a proof for it, and then return the proof to the client. But there might be a situation where ZKVM prover network might fail. So usually ZKVM vendors, since they've built their ZKVM, they're very good at like giving a good performance. So usually they would have like a cluster of machines, and then they would like split the workloads to each machine, and then like orchestrate it, and then create a proof and return. But since most of the such prover network related codes are closed sourced, maybe to handle this kind of network reliability issue, us Chroma might have to implement a code to orchestrate multiple machines so that every validators could I'm not sure if this is correct, but they might have to run a cluster to generate a proof for the network. So another concern might be, so now there's going to be more stage 1 rollups, but for stage 2, we only want the security council to come in and resolve like the problem if the failure is only on-chain provable. But currently, in my perspective, for the ZK VMs, currently there's no way to make like the network failure to be on-chain provable. So that's another concern. And also, since we cannot overlook the fact that ZK VMs itself might have a bug. So what I think is we need a multi-prover system so that we can compensate the bugs for that. So then in that case, the goal would be to enhance the security of the network, but not much with the overhead. So we don't want like periods to be longer. So there might be like 3 types of multi-prover schemes instead of like having a single prover. So one, I think most of the networks like Scroll and Tyco is trying to use T's. But in my opinion, there's a trust issue that we have to trust the T implementation itself. So, and there's also like Hydra centralization problems. So we might have to come up with a clever idea to maybe use like 3 vendors of T's and then like have a multi-sig kind of thing. And another one would be kind of very labor intensive, but come up with another circuit-based ZKVM. So instead of Plonkish and Halo 2, you might have to write another ZKVM code, circuit code, with another language. I don't think no one will try that. And I think the best would be our approach to have another ZKVM-based ZKVM. I'll tell you why we think this is the best. And if we have a multi-prover system and if we have like ZK VMs now, we could really easily ship ZK rollups than like past 1 or 2 years. But I've did some benchmarks with several ZK VMs, but there's still a feasibility issue. So first, there's a cost barrier, which is very, very important. And in my opinion, it would be really, really hard to like charge the users to use it, since like most of the layer 2s and most of the optimistic rollups now have very, very cheap fees. So there are 3 types of costs that we need to pay to run a ZK rollup. First, is the biggest bottleneck, which is the proving cost. So I've tested with like a network with about like 3 TPS, and you need about $1 million for proving the blocks for a year. So I think it's not that feasible now. And also, we would have to commit to the batches we've settled into layer 1. So there will be settlement fees also. And to finalize the blocks, we would have to send the proof to the contract and verify on-chain. So there's also going to be verification piece. But that's going to be really, really small, because we will be able to aggregate proofs inside a ZK VM, which will be way cheaper. But there's going to be trade-off between finality. And also, we could explore more on future directions where I introduce the multi-prover system. And also, the ZK VM vendors would have to consider more about prover decentralization, where they don't keep the clusters running on only their network and getting proof requests, but instead of like have an incentive mechanism so that prover network can be decentralized a bit more. And like we're also at the same time pushing the boundaries of proof generation. So we have our own very unique open source library called Tachyon, which is a particle that's known to be faster than light. And it's basically a modular ZK backend library, and we also have a feature of GPU acceleration. So since we've built our ZK VM based on Halo 2, we first optimized Halo 2 a lot, and we have about like 1.5x, 6x faster benchmark. And we also are trying to utilize SP1 ZK VM at the moment. So we also optimize Plonky 3 as well, which is used by SP1. And last, since Circum is very, very widely used in the community, we also optimize a lot in terms of rapid snark. So it's also faster. And we could wrap up into this one figure where if Chroma has a multi-ZK VM prover backing the network, we would also have Tachyon, which is a modular ZK backend library, which could support all kinds of ZK VMs. So we would only have to maintain the very front like ZK VM main, which is written in Rust, and which mainly uses the library Kona, which is maintained from Optimism, which has block derivation logic and execution logic. So we could easily write a program for our mainnet within like 200 lines of code. And we would have an input which would be the block we were trying to prove. And we would have a multi-prover, like one of the frontiers, RISC-0, SP1, O1VM, Valida maybe. And then we have a Tachyon, which is backing with powerful GPU optimizations, which will accelerate the proof generation speed. Yep, that's it for today. And you can contact me with fakedev9999 on Twitter, Telegram. Please contact. We could share more about fault-proof systems. I would like to hear your ideas. And that's it. Thank you.
Yeah, you can just stay over here. All right, great talk, TA. So thank you to the crowd for submitting all these amazing questions. We do have less than 5 minutes to go through some of them. Let's go through the most upvoted one. How is it different than OP Succinct?
Yeah, some of you guys might know and not know, but OP Succinct and us, we have a very, very similar logic. Actually, we were working underwater for about 2 months, and then we shared it to the SP1 team about oh, we have a Chroma SPO prover repository. You could take a look if the logic would be correct for ZKVM-based prover. And they were also working underwater with the same thing. And like, it comes out that like, we have almost similar logic. And they have an additional feature of what I mentioned of aggregating the proofs. So the logic is very similar, but basically we built the same thing.
So I'm going to mark this as answered. Any stats on prover cost, specs, and time?
So the prover cost for our fault-proof system, for about a block with a TPS of 3 to prove a faulty block of TPS 3, I think it costs about like currently, so it depends on the pricing of the prover network you're trying to use, but if you're just using an on-demand plan, which would be the most expensive per cycles, if I remember correctly, it was about like $20 for a block with like about like TPS 3. And the stats and like the machine specs, it's not revealed at the moment for SPO and prover network, so I'm not sure about that.
All right. Do you know if the ARB ecosystem have similar plans?
Yes, I definitely know, and I also know the fact that they have a fast withdrawal feature now with ZK proofs. I didn't have much time to like deep dive into it, but I definitely think like Arbitrum also is going through the right path, so maybe we could collab more and talk more about it.
All right, great. So we can go through, I guess, 2 more questions real quick. In your prior implementation by Plonkish Circuit, you mean Plonky 2 or 3 or something custom?
Oh, it's actually Halo 2's Plonkish arithmetization. It might have like confused you a little bit, but we're using a backend currently, Halo 2.
All right. So one last question: what happens if the guest program panics? Can you still produce a proof?
So if a guest program panics, then you can't produce a proof. So I'm not sure the person who's asking the question like is intentionally panicking the program or not, but like yeah, if it's a bug that's causing panic, then proof is not produced. So this is another thing I mentioned in the slides before is we need a way to like overcome like if the program panics, like, but if it's a bug inside a ZKVM or if it's a bug in a program, then like we would need to way to verify it on chain or like have a way to prove it on chain so that Security Council could like intervene or what.
All right, great. So our time is up. Thank you so much, TA. So our next talk will actually start at 5. So feel free to hang around. welcome back, everyone. So, up next, actually very excited for this, we have another amazing speaker from the Aztec team, and his talk is on Decentralize Your Sequencer, a guide for L2s. When the speaker slide shows up, there will be a QR code on the side. So feel free to scan that. If you have any live questions, we will be addressing them in the last 5 minutes in the FAQ. So let's give a round of warm applause to Joe Andrews, the co-founder of Aztec, on the stage.
All right, thank you everyone for coming. I know there's a big talk next door about the Ethereum roadmap, so I appreciate you guys for coming to this one. My name's Joe. I'm one of the co-founders of Aztec. We're building a privacy layer for Ethereum, but today I'm going to talk a bit about a general guide for L2s and how to decentralize sequencers. You can follow me on Twitter, and let's dive in. So first of all, we're going to look a bit about our journey, kind of the journey that Aztec's been on, what we've learned, and I'm going to try and convince, hopefully, the L2s in the room, people who work at L2s, to care, and I'll also talk about why we care. We'll talk about why we can't rely on Trust Me Bro. This is something it's a bit of a pet peeve of mine, but we'll go into that in a second. We'll just debunk the myth around forced inclusion being the same as decentralized sequencing. We'll look at the different components of a sequencer, and then, decentralizing a sequencer is just the beginning, and hopefully we'll have time for questions. So back in 2023, we started kind of a process at Aztec. For the last 18 months, we've been thinking about how we decentralize and launch Aztec as a decentralized L2. We're doing this all in public on our forums. You can check out these various RFPs and the responses on our forum. I'll share a link in a second. We've had to think about this a bit before everyone else. Being a privacy-focused layer 2, like the regulatory climate is slightly hostile towards us. We can't be a central point of failure for all of the private transactions that go through Aztec. So we've been thinking about this, and hopefully I can share some of the learnings with you today. Our latest kind of block production designs are now live on the forum. You can scan this QR code. Spoiler alert, we use a random leader election to decentralize our sequencer. There's also a payload timeliness committee on the L2 to help with fast finality and kind of better UX for pre-confirmations. But ultimately, we use L1 to verify everything. And so trying to stay firmly a ZK rollup. All right, so first of all, let's look to see if other L2s care. I pulled some June dashboards last week, and all-time sequencer profits for kind of other L2s are north of 150 million. This is kind of a crazy stat, but you can kind of see all of the kind of top L2s, they're printing multiple millions of dollars per year, and they may say one thing publicly. We're working on it. The next version will be decentralized. There's kind of not really the right incentives to decentralize here. And so my goal with this talk is to try and convince you that A, we need to care, and maybe look at some of the options we have available to us. For a meme, Yoda says it better than me, so yeah, too much money, the centralized sequences they have. In terms of kind of where we've got to and how much money these L2s are securing, users trust L2s with $38 billion today. And so, L2 Beat is great at kind of showing us what's happening. But it's also it's just a scary number when you think about it. When I think about this, it's $38 billion that doesn't live up to the vision of rollups. This doesn't inherit the censorship properties and the liveness properties of Ethereum. Maybe it gets some eventual safety properties from Ethereum, but ultimately this money just relies on Trust Me Bro. There's a central entity in the middle of all these transactions that we all trust to sequence, tell us what the state is, and promise inclusion. And for me, it's just not okay. This meme says it as well. There'll be lots of memes today. Why is this not okay? I think that in order to have like a credibly decentralized L2, like we need to decentralize the sequencer to inherit the properties of censorship resistance, liveness, and safety from Ethereum. You know, eventually we get safety when we verify a proof, or we have the fraud proof window if it's implemented on like an optimistic rollup. But a lot of these transactions are happening, you know, sub-Ethereum block times, and so there's a lot of pending chain finality that is not safe currently. So we need to look at how to make that safe. Some more reasons why we can't rely on Trust Me Bro. Yeah, centralized sequences, they can lie. They can lie about whether your transaction will be included in a block. They can lie about the transactions that are before or after your transaction, the state of the L2. And this can happen for minutes, hours, or days, depending on the state of the system. We've also tried this before, right? Most people are at Devcon because we're fed up with the Web 2 ecosystem. And like, if we wanted to just trust someone with our data, we can use our favorite like new banking app. We can use a database for that. So hopefully we can do better. I think another reason here is in 2024 that censorship is very real. Like as we start to get more and more usage and adoption of crypto, the chance of one central entity sharing the same beliefs of everyone in this room or all of the transactions on the network, it's vanishingly small. And so, you know, as we start to get more interesting use cases, sequencers will start to prioritize one type of transaction over the other, and we can't have that. And the last one, this has been said before, but a liveness failure is still a failure, right? You know, if you get used to, you know, sub-second block times and then it goes down for 5 hours, you can't send a transaction, you can't use your money, your funds are stuck. And so this may be okay for today when we're trading, you know, meme coins, but if you're trying to get to work or use real value, this is not okay. This has been said before, but I like this meme. Okay, so this is like a personal pet peeve of mine. I think sometimes centralized rollups rely on forced inclusion to say we'll do it later, or to keep printing the millions of dollars that we saw earlier. For me, forced inclusion is a bit like this this traffic jam. You know, if everything's great and you're friends with a centralized sequencer, you can use the fast lane. You can get to work on time, and everything's working perfectly. As soon as something goes wrong, you get stuck in this traffic jam. You know, the capacity's not there, you wait for hours, and really, like, you can only use this in emergencies. You may use the right-hand side to flee a country, like run away from a storm, but you're not going to use it to get to work. And forced inclusions are pretty much the same. They can only be used for transactions which have a long duration. And so we want to make sure that every transaction has the same properties for censorship resistance and liveness. And forced transactions are kind of a second-class citizen. All they guarantee is like an eventual sequencing. And we need to decentralize our sequencer to ensure that these properties are the same for all transactions. So yeah, if you leave with anything, please leave with this. Forced inclusion is eventual sequencing, not decentralized sequencing, and we can't rely on it. Okay. So a lot of why. Hopefully you're with me now and you want to decentralize your sequences. So let's look at some of the core components. There's 4 main components. We have leader election, DA, slashing incentives, and consensus. We'll go into each of these in a little bit more detail. But I think the key one is the one on the right with consensus. We need to verify that everything to the left here, these first 3, happen correctly. And how do we do that? You know, how do we verify that the correct leader was elected from a decentralized set? How do we verify that they published enough data for the next sequencer to publish a block? How do we verify where slashing occurs? If we do that on L1, a separate consensus network, or use economics, they all have different assumptions around where we inherit our security and liveness from. So let's look at the first one, leader election. You know, if we have a whitelist, like a sequencing whitelist, and you're not on the list, you may end up like this guy, waiting to be picked as sequencer. And we can do better than this. So Leader election is all about picking who's going to be the next sequencer, and there's a few different ways we can do this. The simplest is a round robin. We can kind of have an ordered set and just cycle through them one after the other in a deterministic order. It works, but the determinism is actually a bit of an issue. You can have denial of service attacks because of this. A better model may be a random shuffle. You can shuffle either sequences or block proposals. Both can work, but they rely on some sort of random beacon to work. Another interesting one is kind of let anyone be a sequencer and actually just vote on the proposals. So you could pick the proposal which makes the most money or solve some sort of optimization problem. And the last one is kind of a combination of some of these. You can take a random shuffle but weight it by some factor. It could be weighted by reputation or stake. So these are kind of the different options available for the first leader election. This does need to be verified somewhere, so it's important to kind of take that into account when choosing. Okay, so the next one is also equally important. If I'm the sequencer and I'm centralized and I want to build block n on block n+1 on block n, I've already got the data. Like I don't need to send it to anyone. I made the last block, so I can just keep going kind of for all of time being this centralized sequencer. That doesn't work if someone else is the next sequencer. So we'll run through a little kind of chain here. The purple blocks are finalized blocks. They're either finalized because there's a validity proof or there's a fraud proof window that's expired. To build a block on the finalized chain, I just need the side effects of the rollup. I need to, all the transactions that have happened throughout the time. I need to have a database of those side effects. I need to move the state from the old side effects to the new side effects to build the next block. So I can build block 4 here. And then imagine we have like a pre-confirmation chain where the sequence is changing quite quickly, but these blocks have not been confirmed now. They've not been confirmed by L1. They're just kind of, they've been confirmed between maybe 3 different sequences, but there's a lot of data now that needs to be shared to build block 6. We still have to share the rollup side effects. We have to have block 5 state, and then we need to apply the state diff from the transactions in block 6 to get the new side effects. But there's this other type of data which usually gets swallowed in a ZK proof or is not posted on chain called transaction auth data. And this is where the problem kind of starts. So for a public rollup, optimism, rollups that don't deal with privacy, ZK Sync, like public ZK rollups have this as well. The data is quite small. So you have a TX request and a signature. It's around 400 bytes. You can post that data. You could put it on Ethereum. You could send it to another DA layer. You can put it in lots of places. For a privacy rollup, the data is it's a lot larger. Like the transaction accompanies a zero knowledge proof, which can be 32 to 64 kilobytes depending on the proving system. And so sharing that data between sequences becomes a bit of a problem, which we'll go on to in a second. Like if you don't have this data, you can't verify that the transactions in block 5 are authorized, which means you don't know if block 5 will happen, so you don't know if you can build upon it. So in terms of DA, like where can this data go? We can put it in core data. It's been around for a while. It's kind of the only way we can put data on Ethereum if we want to use it in a smart contract. It's very expensive though, and limited in capacity. Blobs came out last year, I believe. We like these. They're a lot cheaper, and it's very useful for kind of posting this side effect data. It can also be used to post the transaction authorization data we talked about earlier, but only for kind of public rollups. There's not enough capacity for private rollups to use this. Payload timeliness committees. These are like an L2 specific committee. Like the sequencers can join together, and they can sign off on the fact that enough data exists. They've seen this data to prove the block. If they give a signature and a majority of the committee signs off, then a sequencer can look at that signature and be like, I don't have the data, but I trust this committee. It's like a mini DA layer, but it's very short-lived. And then you can also put it on an alt DA. So there's lots of capacity on these, but they don't bridge back to Ethereum very quickly. So it's only really usable for kind of side effect data, and you can't use it for kind of data that's critical for block production, because then you won't be a rollup. This is just a quick kind of table of the different comparisons. Yeah, you can see kind of you have to pick and choose based on security, throughput that can fit on these different DAs, and what they can be used for. Cool. So the last part is is the most important. Like, we have to verify everything we just talked about. And so usually when we think about consensus, we just think about verifying what happened. Did these transactions produce this state? And that's kind of, that's fine. But when we're talking about decentralizing sequences, we have to verify a lot more than that. We also have to verify, like, how did this happen? If we're waiting for a validity proof, which can take 10 minutes, in some blockchains, in some rollups, it can take several hours, or challenge periods in an optimistic kind of fraud-proof scenario could take 7 days. What do we do in that time to verify that the blocks that are pending actually happened? Like, we need some data. It's the data we talked about on the last slides. And so depending on how we can trust what happened, we may need to kind of also verify data locally as a sequencer to know what happened. And then lastly, like, we need to check who did it. Like, did the sequencer who proposed a block actually have the right to propose a block? And so we need to come to consensus on all of these three things to make sure that the blocks that are being proposed by a decentralized sequencer are valid and follow the rules of the system. If we don't kind of verify who did it, like, someone could just keep proposing a block who's not able to, they could monopolize sequencing rights. And so depending on where we verify these things, we inherit different censorship and different liveness and different safety properties, and they're not all equal. So I think just looking at the different options we have here, the most secure is to be a based rollup. Let's try and inherit everything from L1. This is great. We can, defer sequencing to the L1 proposing set. We can kind of inherit censorship and liveness from L1. Like, if Ethereum's running, you can always propose a block. It's also quite easy to do. However, this is only really possible for public rollups, and it's also quite slow. So you're limited to a block every Ethereum block. Most L2s have a lot faster finality than that, or sorry, faster pre-confirmations. Like, they have sub-second block times, so this doesn't really work. Another alternative is use L1 for ordering, but for this data which doesn't fit on L1, introduce like a payload timeliness committee for the transaction auth data. Have this committee that sticks around for just long enough to make sure that a block can be proven. And this is possible for public and private rollups. It has some pretty nice properties. We get the censorship properties from L1 because L1's deciding who's sequencer. Liveness properties are pretty good if the committee is still honest. And if you have a decentralized sequence set, this is actually a pretty strong assumption. And we inherit safety from L1 as well. Other ways of doing this, are less good. Some people talk about putting, a Tendermint Cosmos instance in front of the L2, have an actual consensus network on the L2. This kind of has, I guess, it doesn't inherit the properties we want from L1. If you have a separate consensus network that's deciding who's sequencer, is deciding if the data's available, and it's deciding, is the state of the pending chain correct? You only inherit the properties of that staking set in the short term. Eventually, you may settle to L1 and have, a validity proof of all of this. That's very complicated to do. You have to prove the consensus of the L2 on L1 in like a mega proof. I think the other thing that's worth saying is that, like, you also would have to reorg your L2 consensus network based on whether that proof succeeds or fails on L1. So it's just messy. So where you sit in this kind of chart depends on, as you decentralize, what you want to kind of give your users. All right, we're running out of time, so I think a few slides left. the last thing I want to go through is like this is just the beginning. Like you can pick where you are in this kind of map of like DA, leader election, slashing, implement all these different things. But it's just the beginning. Like there's no point decentralizing your sequencer if you don't think about the entire kind of like stack. So sequencing is one part. We've got provers, right? If you're a ZK L2 and you're relying on someone to actually prove the validity of all of this happening, and you have one prover, then it doesn't matter how decentralized your sequencer set is because no one can actually advance the chain. So yeah, decentralizing proving is a key part of this, and governance is the last part. Like if governance can overrule any of these two things or change the system, and that's centralized, like there's a centralized multi-sig, it also doesn't matter if you have decentralized sequencing and proving because the results can basically be thrown away. And so to actually fully decentralize an L2, you have to exist in this middle part. And so, doing any one of these in isolation doesn't really work. And this is kind of what I wanted to leave you guys with. Maybe next year I'll give a talk on the other two. Thanks for listening. And you can look at our forum posts here if you want to follow along for some of the other designs on governance and decentralized proving, and follow me on Twitter. And maybe scan the QR code if there's questions. Thank you. All right.
So we're actually a little bit short on time, but we can still take some questions. Let's go from the very first one. ZKP sequencing still costs a lot. How do we guarantee sequencers are run by different actors in different locals, even if decentralization is supported?
Yeah, so the cost of sequencing, there's two things that I think are important in the cost of sequencing. It's like the cost of the hardware and the cost of like the bandwidth needed to run the node. Sequencing zero-knowledge proofs or anything else, there shouldn't be any more additional like hardware requirements than that of like an Ethereum node. There may be more bandwidth requirements just because there's more data if the proofs are larger. And so, you can still get geographic decentralization if you just focus on hubs like universities or areas that have good fiber connections. But the hardware is pretty easy to get.
All right. And which of your users are most excited and empowered by decentralized sequencing on Aztec?
This is a good question. I guess there's people who want to run sequences, but that's maybe an obvious one. But I think like the reason we're decentralizing sequencing is because it creates a neutral layer where you can have very different apps interoperating with each other. And so I think if we look at the types of applications that people are building in kind of Aztec pilots, like there's things like proof of passport, things that like you need a neutral base layer. And so I'd say that any application that kind of is at the cutting edge of its field probably needs a decentralized sequencer and is excited by this.
Cool. And how easy in technicality, in your opinion, that ZK Sync, OP, and other move to decentralized sequencer?
Yeah, this is a tough one. So 2-3 years ago, we had a product called Aztec Connect, and we built it centralized, and we said we were going to decentralize it later. That never happened. So I think this is harder than it looks. I think the research is there to do it. I think it's more of an incentive question. So if you're in these communities, I think this has to come from users. It's not going to come always from core teams because centralized sequencers make a lot of money. It is possible today, but it does require pretty serious upgrades.
And what should be decentralized first? Sequencer, prover, or governance?
Yeah, this is a tough one. My last slide kind of hints that maybe all three have to happen at once. I think in a privacy rollup, that's definitely true. For public rollups, I think you can get away with decentralizing them a bit more one at a time. I've seen some pretty interesting prover decentralization where proofs are happening in TEs as like a second proof, like a multi-prover model. Yeah, I think it can happen one at a time, but only in a public rollup context.
All right, so here we got a question actually from Token 2049. The cost is a big reason why L2s are still centralized sequencers. Decentralized L2 will increase cost, and users don't like it. And what is your opinion on this?
I don't know if it will increase cost. It may increase or make the UX slightly worse, but I think it depends on the type of application. So, if you think about micropayments or fast finality payments, they may need a centralized sequencer to process transactions, but those things should exist as an L3 or like an app chain. So I think it's more of a UX consideration than a cost consideration. Like with decentralized sequencing, we're targeting like between 1 and 10 cent transactions on Aztec, so I don't think the cost argument is there.
All right, I think time for one last question. There is incentive misalignment for centralized sequencers to decentralize. How do we solve this?
That was kind of the point of the talk, so it's on us to kind of talk about this and I think push them to do it. I think, yeah, it's easier to not do it, but one day something will go wrong and we'll wish we had done it. So I think, if you're in these communities, kind of push your kind of core devs to decentralize and start the process.
All right, I think unfortunately that's all the time we have. Thank you so much, Joe, for giving us this amazing talk. Our next talk will begin at 5:30, so feel free to stick around if you are interested. All right, welcome back, everyone. So our next talk is on the topic, are L2s extractive to Ethereum? So a little housekeeping rule. There's going to be a QR code showing up right over here. So please scan that if you have any questions for the speaker. So you guys have like these interesting names that like I don't know what to do. So let's welcome Ren Cryptofish on the stage.
Cool. Thanks for coming. I know it's been a long day. Today, I'll be talking about the topic of are L2s extractive to Ethereum. My talk, I'm going to cover three main areas. The first is on the topic of L2s keeping fees and not paying enough for blobs. This is quite a nuanced topic, and I'm going to dive into it. The second, what I think is a more important question is, are L2s generating ETH-denominated activity in terms of ETH being used as a gas token, ETH being used as an asset, and has it generated new holders of ETH? And I think the third topic that I'm going to touch on is, what is the dynamic between L2s and Ethereum? So if you go on crypto Twitter, if you read forums, blog posts, etc., one of the most popular narratives is L2s are keeping the fees that they're generating and they're not paying enough for blobs. And you can kind of see this when you look at the margins for layer 2s post EIP 4844 going from 20 to 30% margin on fees to upwards of 99.99%. But I think the nuance behind this is that blobs are still in the cold start period. And what that means is that it is a byproduct of the mechanism of 4844. And David Krappus predicted the cold start problem actually last year. And he ran a simulation from March 2023 using assumptions from the transaction volume on Arbitrum and Optimism at that time. And it would take roughly 250 kilobytes per block to get into price discovery for blob pricing. That's roughly 1.8 gigabytes per day. And in some of the later charts, what I'll show you is that we're basically there on average per day, but not yet on a block-by-block basis. And actually, there have been some notable periods when blob pricing has gone into price discovery. This is an example from earlier this year, which shows the blob fee breakdown between blob space fees and execution fees during the layer 0 airdrop. And you can see that for a period of roughly 1 to 2 hours, blob fees actually dominated compared to the execution fees. And actually, more recently, blobs have been getting really, really close to the target amount of blobs, past which the blob pricing would go into price discovery, and you would see this drastic increase in the cost of blobs faced by the L2s. But one of the interesting dynamics behind this is that layer 2s are fundamentally businesses. And when you see a fee spike for blob pricing, we tend to see that layer 2s actually start to slow down the pace that they post blobs in order to dodge these high spike moments. Another way to see this is through the distribution of blobs per block. So the gray color are blocks with no blobs. These blocks serve as a temporary buffer where, for instance, you might have a day where the total amount of data posted might imply that the blob fees should go into price discovery, but that mechanism is actually triggered on a block-by-block basis. But we're going from a world where half of the blocks had no blobs to a world where only 20 to 30% of the blocks have no blobs. And the same is true on a capacity basis. So in the summer of 2024, roughly 20 to 30% of the data capacity in terms of bytes was unused, and now we're approaching a period where only 10 to 20% is unused. And overall, blobs inflow per day are quite healthy. They're actually well above the 1.8 gigabyte target, through which, if that were true block by block, blob fee pricing would go into price discovery. So I think we're actually well on our way to that. So now that I covered some of the nuances behind the blob fee market, and that it's not necessarily a byproduct of the L2s not wanting to pay for blob storage, it's more that the way that the mechanism is designed is what is precipitating what we're seeing for the blob fees at the moment. So the second topic I want to dive into, which I think is the more important topic, is are L2s generating activity and usage of ETH, the asset? So if you look at L2Beat and various block explorers, I'm sure everyone has seen a chart that looks something like this, where the L2 activity has grown tremendously over the past year, going from around 50 TPS up to 170, 180 TPS across the L2s. But L2's usage of ETH as a gas token has only grown modestly due to lower L1 settlement fees despite higher activity. That's partially contributing to things like lower burn, a lot of concern from the community. But again, this is more of a byproduct of the mechanism of 4844 and less about any nefarious intention. But I thought this chart was actually pretty interesting. So if you zoom out and you look at the collective fees in terms of ETH being used as a gas token, and you compare that to the gas fees used on mainnet, you can barely see the L2 line, which is great for users in that their transactions are quite cheap, but potentially some concern around the security of mainnet. On the flip side, the L2 usage of ETH as an asset has grown tremendously. So what we see here is a chart of the total value locked, stacked by type. The purple on top is the canonical bridged ETH. And that's just gone pretty much up only since L2's launched. So in summary, to cover the first half of the talk, in terms of the current state, there is not enough L2 blob demand to consistently get blob space into price discovery. That requires consistently block by block L2s consistently posting blobs in order to trigger the price discovery mechanism behind 4844. But I think we're almost there. Blob pricing today is currently in a bootstrapping period. It has shown periods of price discovery. This is known. It's been posted on the ETH research forums in 2023. There's nothing inherently wrong with the network or the way that the pricing is working. And it's actually approaching data inflow levels that would actually start to trigger and begin price discovery. And looking at activity on the L2s, we do see a lot of new usage of ETH as an asset in terms of being used in staking protocols and DeFi and et cetera, but very minor usage of ETH as a gas token relative to mainnet. So the second half of my talk, I'm going to talk about the dynamic between L2s and Ethereum. So at the limit, L2s and mainnet appear symbiotic. Tim Robinson had a great post, and he actually built this really great calculator where he shows that he's showing a scenario under which Ethereum, for Ethereum's blob market post-surge. So what this shows is a simulation for 10,000 TPS across L2s, which is pretty feasible and reasonable, I think. 16 megabytes of blobs per block, and that would imply a 6.5% yield on ETH, given some reasonable user price sensitivity assumptions. So what that means is when the transaction fees go up, a smaller percentage of the users are willing to transact at that price because they might be sensitive to higher transaction fees. But I think where we are in reality is here, where we're at this temporary lull where the L2 fees are very low, and we're in a period where we're probably most likely going to exit the bootstrapping period of blob pricing, and we'll likely see a period where the L2 fees tick up. So for example, in this scenario here, this uses the current specifications based on 4844. In this scenario, it assumes 5 rollups, 300 TPS per rollup, the same user price sensitivity assumptions. And what you can see in this chart, and I think the interesting line to call out is the green line, which is the actual TPS. That reflects user sensitivity to higher transaction fees. And in my opinion, 5 rollups and 300 TPS, if you look at the number of projects kind of in the pipeline, that is pretty doable in terms of what we might expect to see over the next year. And what we can actually see in this chart is it implies that the Ethereum blob market could potentially serve as a constraining factor on the ability for these rollups to increase their throughput and increase activity. So in terms of the question, are L2s extractive? I think the question is actually very nuanced and is actually quite complicated. And I think the true answer is that we don't actually know. And I think there are 3 reasons for that. The first is the L1 settlement fees have never actually been high enough to test Ethereum's network effect. So what that means is we've never actually seen a scenario where L2s have been faced with increasing L1 settlement fees. So we're really uncertain about how the L2s might react in that type of scenario, whether they might look to an alternative DA solution, whether they might be forced to decrease their margins, whether they might potentially even become an L1 on their own. So I think that first scenario, we've never actually really seen that in practice. So we don't really want to impose that judgment upon the layer 2s. So the second point is that there's a lot of value for L2s being L2s, and I think beyond just the label of what people might say, oh, like I'm going to launch an L2 on top of Ethereum, what they actually get is quite a lot. So imagine having to write your own block explorer, your own virtual machine, your own smart contract programming language, recruiting developers to learn your smart contract developing language. And I think the reality is that the L2s are relatively new. And because they are relatively new, they benefit tremendously from being able to bootstrap their virtual machine, tooling, developers, users, community, assets from Ethereum, and even in terms of applications as well. And I think the third reason why we don't actually know whether L2s are extractive today is that most of the analysis in terms of even Tim Robinson's dashboard tends to assume that you have n equal sized L2s, which one might consider the current state, because we're kind of in this moment in time where there isn't a clear breakout L2 winner. And whether you look at TVL, whether you look at transactions, whether you look at number of wallets, whatever metric you look at, generally you tend to see fluctuating periods where you have 3 dominant L2s and they're all splitting market share at different points in time. And I think that type of analysis and thinking about the current state is probably not likely to hold into the future. So it doesn't really consider the case where you have 1 or 2 L2s that take 80 to 90% of activity and economic value, whereas the remainder have marginal economic activity. And I think this is actually a really important case and scenario to think through, because when you look at these financial networks, generally you do tend to see power law effects. And I think the scenario in which you have 1 or 2 very dominant L2s, the question about where does the market power and the leverage between the L2s and mainnet, at what point might that flip? And I think probably more work has to be done on that side. So in the final few minutes here, I want to talk about some of the hypothetical conditions where L2s could become more attractive. So the first is about if the L1 has limited transaction processing capability. And I think this is important because I think, first off, the economic situation of ETH, the asset, could become more risky if the amount of fees that are being generated on mainnet are not high enough to ensure that a large portion of the network ends up being staked. I think L2s also tend to benefit from highly developed financial system on the L1. And I think the second scenario, which I talked about a bit earlier, is the case where you have a power law effect for L2. So for example, a dominant L2 would be the majority blob purchaser. And with very clever batching, they could potentially pin blob pricing below price discovery. That's actually happening organically today. So if you look at how the L2s behave in periods where blob pricing does spike, we're already seeing behavior that suggests that they're willing to spread out how quickly they sink their state across time. And the consequence of that is that users who might want to look for a unilateral exit from the L2 might not be able to do that if the L2s are being more cautious and doing more optimization about how frequently they post. The next hypothetical scenario is a case where the incentive structures for L2 tokens or non-ETH gas tokens become more prominent. So if you look at the breakdown of activity on L2s and you look at the split between the L2s that are using ETH as a gas token and the L2s in quotation marks or L3s that aren't using ETH as a gas token, today that split is actually 50-50. So I think the notion that every single rollup necessarily has to use ETH as a gas token, we're already seeing some scenarios in which that might not necessarily be the case. And I think that's related to one of these other points, which is the notion of a siloed L2 with their own settlement kingdoms for L3s or similar types of rollups. That's another scenario in which the L2s might push for an alternative gas token, which again would not benefit ETH as an asset. And I think the final point is potentially incentive structures for L2s in which they start to develop competing security models in terms of being able to use their native governance token for things other than just governance could potentially be a condition in which the L2s could also become more extractive. So that concludes my talk. I think it's still ultimately too early to tell in terms of whether the L2s are extractive or not. The reason for that is we've never actually seen a scenario in which the L2s have been put in a position to make a choice, whether they stay as an L2 or they use an alt-DA layer or they become an L1 or they do something else. But I think that time is actually coming very soon. So probably likely over the next 1 year, we'll start to see some of these choices being forced just by the nature of the blob fees going into price discovery. Thanks.
All right, thank you, Ren. You feel free to come to the center over here. Yeah, this one will be fine. So let's go over some questions. Let's start from the first one. Do you think the exact copy of EIP 1559 mechanism determining L1 fees is the right approach for determining blob fees?
Yeah, I think this is a really tricky question. So I think where my mind jumps immediately is I look at the amount of execution that has been moved off from the L1 to the L2, and the amount of transactions on the L2 today greatly outweigh the amount of transactions ever in Ethereum's history in terms of like per second or per block. But in terms of the in terms of ETH being used as a gas token for those transactions, it's actually quite minimal even compared to like the earliest periods in like Ethereum's history. So I think one of the things to consider is that that ratio might be slightly off. And I think the only way you really see that settle is blob pricing has to go into price discovery, which means there needs to be more L2s, and that will likely happen over the next year.
Cool. And another question. Currently, the L2 mainnet seems symbiotic, but what if they started paying fees in their own tokens? They have a fair amount of incentive to keep assets logged in their system without interoperability.
Yeah. I talked to this point in the last slide about hypothetical scenarios. So I think some of the highest forms of risk are exactly that. So for example, L2s in their current state as having their tokens as a governance token, it's highly likely it's probably more likely that changes in the future than stays the same. So I think that is a very real risk.
Have you or others been able to isolate the decrease in L1 execution demand due to real transactions from the reduction in call data demand? Will L1 execution demand go to 0?
So I don't think L1 execution demand will go to 0. So a chart that I didn't include, just because it's a very basic chart, is that the number of transactions on Ethereum has actually not gone down, and the amount of gas in terms of gas consumed has not gone down. It's that the nature of the transactions have changed. So historically, the transactions on Ethereum had been transactions that had a lot more right conflict or right contention, and right contention leads to higher fees because people want to people tend to be rushed in terms of those types of transactions. So for example, like if people are trading various forms of assets, there's a high degree of urgency that those transactions land. But most of that activity, at the moment at least, has shifted to the L2s.
Perfect. And how to prevent a single L2 from eating up all the space or spotlight, aka base, not from the tech perspective, but from the marketing public perspective?
Yeah, so I don't necessarily want to call out a single L2, but I think the hypothetical scenario of an L2 becoming the dominant L2, where 80 to 90% of the economic activity flows through there, I think that's a very real risk. I don't believe there's been very many payment networks in the past where you haven't seen a monopoly or oligopoly type of structure just due to the nature of network effects in these types of financial systems. So I think that risk is very real.
Perfect. And I think this is a great comment to close off the speech. Thank you so much. All right, thank you guys. Our next talk will begin at 6. Well, hello, hello. How's everyone doing? Wow, high energy. This is our last talk of the day. So, very excited. We have Remco Blumen from the World Foundation to give his talk on exploring proof of personhood, privacy, biometrics, and why it needs Ethereum. So a little housekeeping rule. We're going to have the QR code here on the right. So feel free to scan the QR code if you have any questions for Remco throughout his talk. We will be addressing them at the very last 5 minutes. So let's give a warm round of applause to Remco on the stage.
Hello, Devcon. So, Remco from the World Foundation, and I'm going to be talking about a thing we're doing, which is proof of human, otherwise known as proof of personhood, but that's a bit of a misnomer. We'll get into that. And how we do this in a private way using biometrics, and why we need Ethereum to make that happen. So quickly, what is proof of personhood? The short version is, it is a way to limit account registration to a few, ideally one, per human being. That in itself doesn't give you any kind of privacy. In fact, it usually gives you the opposite. But you can add a layer of zero-knowledge proofs on top of that to get a slightly richer primitive, which is being able to sign messages as a unique anonymous human. For example, within some context, you can sign a message proving that you are a human being that has not signed a message in this context before. You could do, let's say, hey, dear project, please claim my airdrop to this address. Signed, an anonymous human. Or, dear DAO, please allocate my voting shares to this particular vote. Signed, an anonymous human. Or, dear Farcaster, please register my handle as belonging to a unique human being and not a bot. Or, dear Farcaster, and this is where it gets interesting, please register this other handle as my alt. Because it doesn't necessarily mean that you're restricted to one account per human being. You can have multiple accounts. It's kind of up to the application developer to specify what the desired behavior is. It is a programmable primitive that we're adding to the blockchain. What is it not? It is not, very importantly, a CAPTCHA. A proof of personhood does not prevent a bot from doing something. It just means that this action was initiated and kind of signed off by a specific human being. So you can still automate your accounts. Now, why do we want proof of personhood? At a high level, AI will make it impossible to distinguish on behavioral features alone, at least in the digital domain. And AI-fueled economic disruptions require us to get much better at creating human-oriented financial solutions to solve any economic hardship that might happen in the world. Therefore, we need to add individuals as a programmable primitive. It is also critical to get strong decentralization, because the only way to make sure that many, many people are involved in consensus making is through a form of proof of personhood. This in turn unlocks financial primitives with a concept of individuals, and a lot of them have that. Insurance, loans, pensions, universal basic income. None of these we can currently do with programmable money because we do not yet have programmable individuals. We're changing that. And that allows you to do cool things that kind of I didn't even expect when we started this. Like the World Chain L2 that we just launched has prioritized block space for humans. So if you're a human being, you get priority over the trading bots in the sequencer. And then, of course, there's the basics like Sybil resistance and preventing spam bots. Now, why would you not want proof of personhood? Unique human can often just be a proxy for something more precise. That is what you really want. Like when it comes to, let's say, under-collateralized loans, you're not necessarily interested in a unique human being, you're interested in someone's credit worthiness, and there might be better tests for that you could use directly that would, in the end, create a system that abstracts better what it is aiming to do. You could also imagine a social media platform where you don't really care whether someone is a human or a bot, as long as they make valid, meaningful contributions to the discussion. So here again, there is a trade-off for the app developers to make. Like, is proof of personhood actually what I need here? And there's kind of like an argument that you can make that if you really aim for maximal anonymity, not even the number of humans that are currently in your system should be transparent, which is something that, of course, proof of personhood achieves. Okay, now that we've covered what it is, how do we build it? How is it constructed? The main problem you're solving here is the oracle problem. You're trying to build some information in the Platonic, ideal, cryptographic, trusted domain that comes from the outside, that comes, in this case, from the physical, real world of humans. And solving oracle problems always means some form of compromise, and the question is, what is the best trade-off for the specific problem you're trying to solve? The three main approaches for proof of personhood are authority-based, where you use some existing authority like a government or an email provider or a bank as a trusted entity to have a list of all the humans. Others are graph-based. These are decentralized. And here you have humans essentially verifying other humans, or you take some approach to pairwise distinguish humans from each other, and then turn that into a larger graph. I'll get into more details on each of these in a moment. Biometric-based is recognizing that humans have a physical body and doing measurements on that body to distinguish it from other bodies. Now, the authority-based, this is the conventional solution. This is what the whole Web 2 world, the non-crypto world, uses when they need anything remotely resembling proof of personhood. For example, when they issue you a loan, they will ask you to KYC yourself using your government-issued ID and so on. This is an advantage because this means that the average person is familiar with them, that a lot of people have access to these means of these modalities. They're easily scalable and easy to implement. The downside is that they are imperfect when it comes to uniqueness. Passports are relatively good, but still people have multiple passports, and definitely over lifetime, people renew their passports. They also have weak inclusivity. A lot of people don't have access to these means. And of course, there is the central authority problem. We've all heard of SIM swapping. Phone numbers kind of suck in general for any kind of authentication. It's also active. You need to go through this process. You need to actually make sure that the person presenting you the passport matches the document. You also need to make sure that the document itself is a valid passport and not some copy. And this becomes substantially harder in the digital domain, and a lot of the current solutions could do a better job on these steps. And if we don't deploy any kind of zero-knowledge proof methods in here, of course, it's enormously revealing in terms of privacy. Fortunately, there are ZK solutions for all of these, and you can get them to a very high standard, which is great. Now, the graph-based ones, their main strength is it's decentralized. That is the superpower of this particular class of solutions. The downside is that, the main downside is a so-called click attack, where you have a group of bots that keep verifying each other as real humans. So you get a lot of signals on these bots that they're real humans. And once you have a network like that, it's very hard to get this out of your graph-based system. There's a couple of different approaches here. Social graphs is an easy one where you just go to your friends and provide proof to each of your friends that they're all real humans, and you collect it from your friends, and this body of evidence builds up over time. Other solutions that don't require you to reveal your circle of friends are based on video calls, where you either post a video of yourself online showing that you're a real human and then have other people accept or reject that, or you go into Zoom calls with people cross-verifying each other that they are indeed in the Zoom call and indeed are real humans, and building the graph that way. I think both of these are very flawed ultimately, because we have deepfakes. It's very easy to nowadays create realistic video calls. It's also just an awkward, non-scalable process. One that I do want to highlight, because I just think this is such a clever solution, is simultaneous CAPTCHA solving. So the CAPTCHAs I mentioned before are designed such that only humans can solve them. Now, if you, through a blockchain or some other means, trigger, let's say, 5 people to solve a CAPTCHA simultaneously, now you know that there's at least 5 different people there. Biometric based. This is the strongest approach. It gives you near perfect uniqueness. It is non-transferable. You know that it is this human, and this human cannot give this modality away to some other human or sell it or so on. The weakness is it's immutable. It sort of sticks to you for your entire life, which might not necessarily be desirable. You might want to have like some ability to reset. It also relies on trusted sensors. You need a way to capture this biometric information, and it requires physical interaction. The other thing is the so-called false match, non-match rates, where faces with the current algorithms are only unique up to maybe 1 million individuals. And after that, the algorithms will not be able to distinguish them anymore. Same thing with fingerprints. They're not as unique as you would want them to be. Irises, however, have an enormous amount of entropy in them. So they work at a world population scale. And that is the main reason world went in this direction. Now, 2 common misconceptions about biometrics I do want to address. A biometric is not a private key. Your fingerprint is, in a sense, not a secret. Like, you leave it on every glass of every restaurant you've ever been to. And this fingerprint is not what is you. The thing that authenticates you is the fact that you have this fingerprint on a real-life finger attached to a living, breathing body. The second thing is, irises and retinas are not the same thing. So please get that right if you criticize World. World's approach, at a high level, we have a tiered system. We recognize that there's different trade-offs to these different modalities, and we offer a tier list of what we think covers the whole spectrum of what you might want. We have the orb, you see one right there, which is a hardware-based biometric iris-based system that gives you super high guarantees, but you need to go find an orb in order to sign up. We're now rolling out a ZK NFC passport-based system that gives you high privacy and can leverage existing national ID system. And then we have a very low-tier system that uses the TEEs in your mobile phones to prove that you have a unique mobile device. Now, with that last tier, you can obviously see the issue there. You can just buy more phones. And that is kind of the thing with a tiered system. You want to make your trade-offs as an application developer based on what your needs are and how you want the onboarding experience to be. How did we implement this? So we make use of modern cryptography. Generally, when state is local or global or public or private, there's different things we can do. But we now have a full set of solutions here. We can kind of take any kind of problem and come up with a very adequate solution. The high-level strategy is we take our modality. This always starts with some form of trusted sensors. Either the trusted sensors are other humans in the network, or the trusted sensor is the trusted sensor is an NFC chip in your passport, or it is the orb. The orbs are manufactured, they're registered on chain, which is how you can verify that they are authentic through their public key. These then interact with the user's wallet to produce secret shares in zero knowledge. So we know that all of this is done correctly, and we now have secret shares of the modality. that we can then send to a private uniqueness solution. This is implemented using multi-party computation, which also runs in TEEs, which also goes through on-chain governance. And that verifies the uniqueness. Critically, it does this without ever seeing the raw modality. It only sees encrypted and processes encrypted data in the encrypted domain, which gives you a tremendous amount of privacy here. It really sets a new standard. Then we have, as a second layer of defense for your privacy, we don't issue you some sort of Ethereum address that is now blessed. We issue you an anonymous credential. You become a member of an on-chain set that you can zero-knowledge proof membership of. And this makes it such that you cannot track the behavior of any human that signed up through the system. You cannot associate them to the modality that they signed up with, and so on. Now, already covered the orb. This is our very sophisticated device. There's other talks about this that I recommend to go in depth on how it works. I do want to highlight a little bit about the challenges of doing this biometric uniqueness check in multi-party compute. The scale is enormous. We're talking about a 24 NVIDIA H100 GPU cluster that requires almost a terabyte of GPU memory and terabits of communication bandwidth just to sustain the 8 million users that have signed up at a rate of 10 new users per second. Multi-party, as you may know, has trust assumptions. It is important that the nodes are operated by non-colluding entities. For that, we are working with reliable third parties we found. They operate the nodes for us. The world organizations do not have access to these systems. And as a further layer of defense, we have developed technology that allows us to run these CUDA NPCs on GPUs in TEEs, so inside trusted execution environments, so that they can prove that they're all running the protocol honestly, and they cross-verify each other before they even initiate the protocol. Then the question is, okay, what protocols are they allowed to run? Can they do a uniqueness check? Yes. Maybe in the future we want other functionality. We want to have people the ability to recover their accounts through a biometric, for example. That requires some form of governance that can then on-chain sign off on what are the allowed protocols to run, which protocols meet the criteria for privacy and the commitments made to the users. So this is where modern cryptography and Ethereum specifically, programmable consensus, are critical in making all of this work. Now, to summarize, World ID offers biometric, passport, and device-based proof of personhood tiers. You as an app developer can integrate this depending on your needs. We implemented all of these such that the modality, the actual underlying information, never leaves the user. No one outside of the user learns about the passport, learns about the iris, or anything else. And then we have this additional layer of zero-knowledge-based anonymization on each use. So even if you have a DAO where you have a one person, one vote, you will not be able to track voting patterns of users. Each vote is individually unique by default. But of course, as an application developer, you can ask the user if you want different behavior here. Now, covering some next steps, we've recently rolled out mini apps, which is a good way for people that have a use case that requires proof of personhood to immediately reach an audience of millions. As I mentioned, we have WorldChain, which is our L2 that users by default get an account on. And it is experimenting with ways that we can integrate individuals and humanness in how sequencers prioritize the transactions and how fees are allocated. We're currently working hard on improving the technology of client-side proving to get really fast client-side proving, so on device, on your mobile device, producing zero-knowledge proofs. And we want this because there is a big future in doing programmable zero-knowledge identity, meaning that not only can you prove that you're a unique person, but you can prove things about yourself. You can prove that you're of a certain nationality, or not of a certain nationality, or of a certain age, and so on, without revealing anything else about yourself. And with that, I want to open the floor for any questions. Thank you.
All right, thank you, guys. Thank you so much for the amazing talk. We do have 5 minutes to go over some of the questions that people submitted. So it would be great if you can come here in the center. Yes. So let's go from the very first one at the top. What if human creates a proof and sells it to AI? As there's no identity attached and it's zero-knowledge proof, there's no consequence to sell the proof or keys associated with it.
That is correct, and that is intentional. Like I said, this is not a CAPTCHA. This is, you're still allowed to have a bot operate your account. But if you were to do this, you cannot bypass rate limits, for example. You would still be a single account on whatever system you're running it on. So if you want to if you want to run a Twitter bot as a unique human, you can. But if it starts spamming the system, it is obvious that it is one account.
Cool. And what if World ID system gets hacked or becomes hostile on its own, aka Evil Orb?
So World ID as a system is a set of smart contracts and a self-custodial wallet. That doesn't mean it's unhackable, but it means it's subject to the same assumptions as hacking and Ethereum, hacking the Ethereum network and hacking a self-custodial wallet. But the other question about the orb itself is a good one. And the way we tackle that is, like I said, through transparency in how the orb itself operates on-chain. So first of all, the orb is fully open source, open hardware, open firmware. It has a removable SD card so you can verify the build and so on. They're all registered on-chain. And while the process of users and the users signing up is entirely anonymous, the behavior of the orb is not. So it is public how many signups a certain orb does. And if there is any suspicious behavior, that can be flagged, and the multi-party compute setup can actually revert these fraudulent signups.
Another question. Is iris photo hard to capture? Can it be scanned when I'm sleeping?
No, it cannot. It's actually surprisingly hard. The orb, despite being open hardware, unfortunately contains custom optics that you can't really get off the shelf. You need to find someone specialized in making lenses to get this done. It's a hard problem of getting a high-resolution picture of something the size of a sugar cube that is bouncing around 1.5 meters in front of you, and the orb does it. It's quite amazing. This is a good thing, though, because this means that there is a strong form of consent, kind of consent in getting your iris pictures taken. It's very hard to take iris pictures of someone who doesn't actively and willingly participate in the process.
How does World earn income?
I pass. No, really. We currently don't have any issues here. Everything is in production. Everything is running. And this is the space of identity is such a gigantic opportunity that goes way beyond the entire current crypto space. And then itself, the World project will already onboarded tens of millions of people into blockchain, but will onboard many, many more.
How about artificial fake irises? The orb could theoretically think it registers real humans.
Yeah, I think I haven't covered enough how important it is for any kind of biometric sensor to verify that it's not enough to just take a picture of an iris or a fingerprint. You need to make sure that this is from a real life, living, breathing human body. Because otherwise, it could just be someone holding on an iPad or someone trying to squish a silicone mold on a fingerprint scanner. The hard part in designing any kind of biometric system is not so much the capturing of the raw data, but it is in validating that it actually came from a real human being.
Cool. We have 30 seconds to go through one more question. Can someone with an orb produce IDs for non-existent irises?
No, even if you have an orb in physical possession, it is near impossible to make it do those kinds of things. It has like a very strong amount of physical security in it and tamper protection and so on.
All right, cool. So I think that concludes our talk today from Remco. Let's give another round of applause to Remco for his talk to end the day. Yes. Yes. Thank you everyone for coming. Just some closing remarks. How does everyone feel? Oh, amazing. So thank you guys so much for attending today's talk. Tomorrow, the talks will begin at 10 a.m. So usually we start at 10 a.m. sharp. So see you guys there.